Cek one. Cek. Belum Pak? Cek. 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 Cek one. Cek. 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 Cek one. Cek. Cek. Tes. Tes. Cek. 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 Cek one.
Tes. Halo. Tes. 1. Kok kecil? Halo. Tes. Tes. Mic. Speaker sini. Tes. 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 Yang mana, Pak? Tes. Tes. Oh, ikut tinggal naik turun aja. Iya. Tes. Tes. Naik lagi, Pak. Tes. Tes. 1 dia. Oke. Sip.
Cek. Cek.
Mr. Bagus, please share the virtual background. Please make me the host so I can share my screen. Okay, good morning, everyone. I hope you can hear me clearly. So I'm one of the committee that will organize the online session. Today, right now, we are going to start the technical meetings to prepare the online session for all of us. Okay. Wait a minute. Okay. Can you see my screen?
Yes.
Yes.
Okay, thank you. Okay, my name is Hilal. I'll be chairing the. I will help you. I'm one of the representative of the organizer. So here we are going to discuss about several technical aspect of the meeting of the presentation session. Okay, so the conference venue is on Aston Kuta Hotel Residence. If you come there, this is the location. But if you do it online, virtually, you need to go here. Okay, and then we have a couple of rules regarding the online and on-site presentation. So this is the detailed rundown. Hopefully you have already looked at this. Wait a second. Look at this announcement. Okay. This one. Any one of you doesn't know the schedule, the presentation schedule? Okay. Hopefully, all of you have seen it. Have looked at the schedule, so you will not miss the presentation schedule. So the presenters should be ready in the meeting room, either using Zoom or on site, at least 5 minutes before the scheduled time. During Zoom meeting today, so we have to Zoom Zoom link. This is today. This is that we are using right now is the first day of APWiMob. So the presenter's profile name must be set as follows. So starting with the presenter, session, and your name. Total duration for one slot presentation is 20 minutes, which is flexibly divided into presentation and Q&A or question and answer. Maybe the question and answer is about 5 minutes. The session chair may start the session by him or herself and call the presenter one by one to present their paper. Presentation will be conducted by presenting the presentation file or playing the video, the recording videos. So please mention your selection in the beginning of the session. In case of you have already you choose the presentation video recording, make sure that you have already sent us your video, so we don't need to wait for the downloading the videos or getting the video from the ADA system. During the session, presenters should turn on the camera for online presentation. Okay, any question for this? I think it's clear. That's very clear. Okay. All conference participants are encouraged to ask questions and discuss with the presenters within 20-minute time slot guided by the session chair. The presenter may also share his or her own presentation slide when answering the question. If the presenter doesn't attend or doesn't present, the video presentation will still be played without Q&A session, and the paper will not be submitted for inclusion into the APWiMob Explorer. So make sure that you will attend and you will answer, or you will give you will discuss the question by the attendees. Okay. We recommend using PowerPoint for all users, but we also accept Adobe PDF presentation. If you want to use something else, please send email to info@apwimob.conf.org in advance of the meeting. So our IT staff can ensure that your presentation will work properly. All on-site presenters are required to give the presentation onto the computer of the assigned presentation room no later than 10 minutes before the session start, or give their presentation to the committees when they register. Okay. Also, if you haven't finished your manuscript revision, these are the following that must be done. So please revise your paper. Please read carefully our reviewers' comment and reflect them to improve your final papers. If you disagree with some reviewers, you may also give some justification why you didn't agree with the suggestion by the reviewers. For the presentation and also for the paper, English is the working language of the conference. So if English is not your native language, please have your papers read by a native English speaker, on look for online services of proofreading to improve the language of your paper. Also, please note that your paper is subject to further review, and it may be rejected if the English of the paper is not acceptable. Okay, this and also okay. Let's move on. Okay, the paper for paper presentation using doc or docx and latex format template. Paper must be written on A4 format page according to the APWiMob template manuscript, with a minimum of 4 pages and maximum 7 pages in length. Submission exceeding 8 pages will not be accepted. Papers must be written using the APWiMob conference proceeding style format with 2-column and 10-point fonts. For more information on APWiMob style format, you can see the APWiMob template manuscript. So, and also the APWiMob template manuscript can be found here in the link, and you may download the template using this link, both for docx Word document or also for the latex. Especially for conference latex template, you must change the letter format to A4, because by default, if you download it from the APWiMob website, the website will give you the letter paper format instead of A4. So you must change it manually. The papers should not have page number and headers format. So make sure that headers and footers is clean, are clean. No, nothing there, including the XXX something. If you use the APWiMob format, usually the format also give you something like this in the XXX something in the footer. So make sure that you have removed that one. The most important issue that every author so pay attention is to make sure that all the fonts used in the paper are embedded and subsetted. Make sure that you are using Times New Romans for all part of your paper. Because if you don't use, if you use the format, they state that all the papers must use must use the Times New Roman font. Okay, especially papers from Asia and Europe, failure to embed subset fonts is the biggest obstacle to make PDF compliant with the APWiMob Explorer. And make sure that your PDF files are compliant with the APWiMob Explorer. Paper failing to meet the APWiMob Explorer requirements may be rejected. And also make sure that paper similarity is under 30%. If the paper similarity is higher than 30%, the paper will not be submitted for inclusion to the APWiMob Explorer, and therefore the paper will not be published. Okay, these are the following important issues. And first, disallow header. So there is nothing. The header of the paper before the title must be clean. There's nothing there. The minimum font size for most common text in points, you can see in the conference template. The text is by default is 10, and other part maybe maybe the title it can be higher, and for the table it may be smaller. Do not allow scan or bit image papers. Scan paper cannot be checked for similarity. So papers, all text must use use text. Don't use figures. Don't use image for text part of your paper. And do not allow encrypted papers, because encrypted papers cannot be checked for similarity. So make sure that you don't put any password on your paper. Do not allow print-only papers. Print-only papers cannot be checked for similarity as well. Check that PDF has no bookmark. This is required for APWiMob manuscript. So no bookmark in the manuscript. Disallow form fields and disallow link. So you must remove the on links, including your email. Usually by default, if you use email, if you put email on your manuscript, the paper will usually Microsoft Word will automatically make a link for your email. Also in your references, if you cite some website with URL, usually it will be converted into a link, hyperlink. So make sure that you remove the hyperlink. That you don't remove the URL, but you can remove the hyperlink. Okay. Disallow annotation notes in PDF. Enforce gutter width only for 2-column papers. And we will give you a week to fix your final manuscript after this presentation. Maybe the session chair will give you a couple of comments regarding your manuscript. And one more thing, maybe it's not displayed here, is make sure that also your references also in English. Okay, so references also in English. If you have some references in non-English, make sure that you have translated the title into English. Okay. Any question? Okay, I will give you a couple of information that I put here. So I will convert it into PDF and send it to you.
Yeah, hello.
Yes.
Good morning. Thank you for assistance. I wanted to find out for our sessions and
Okay.
for
Yes.
our sessions, would we use this link for the session, or will be given a link for the individual sessions?
Okay. Let me share it with you. Okay. Have you seen this file? Have you received this file? Or maybe you can see it in the website.
Okay.
Okay. So I'm not sure. I'm with Mr. Kobe, right?
Yeah.
Okay. So I'm not sure if you are on the first day or the second day.
No, I'm on the second day.
Second day. So the second day will not use the same link. So I think we send you the using email regarding the second day Zoom link. Please check your email so you are sure with it.
No, it hasn't been sent to me. I was actually supposed to be there physically, but because of issues with respect to my visa,
okay,
I couldn't. So it was only yesterday that Dr. Fabian sent me the program, the link for even this program. So I don't have the link for the second day, and I'm
I see. Okay,
the last presenter on the second day. So
okay,
I asked
so you are the last presenter of the second day.
Yes.
Okay, but let me clarify a couple of things. So you are on the second day tomorrow, right?
Yes.
So you are either in room B or room C for online.
Room B.
Room B, okay.
5B.
And 5B. So you will be chaired by Pak Doni Putra Setiawan, and the time will be 16:20 to 17:30.
Yeah.
Make sure that you are familiar with this time region.
Yes, please.
Okay, so we are fixed with this, and now I will send you. What's the best way to send it to you?
Or you can send it to my email.
Okay, send it to your email. Okay, yes. Okay, so we will send you your email. So you are with Mr. Kobe, right?
Yes.
Yes. Okay.
I'm sending you my email right now.
Okay. Okay. You are using chat.
Yeah.
Thank you. Okay, but also in the chat, Mr. Wijayanto has already sent the hyperlink. So just in case you miss the email, you can save that Zoom link.
Okay, for the second day. Okay.
You see it? You see it?
Yeah, I've seen
in
it.
The chat. Okay, so just keep it. But I will also send you this.
Thank you,
Mr. Obeng.
Okay, thank you.
Hello, Dr. Hilal.
Yes.
I'm Aisha from UTM. Can you hear me?
Yes, I can hear you clearly.
Okay. If we want to present using recorded video, do we need to send it to you? The recorded video first?
Okay, for the recorded video, please send email to the organizer, info@APWiMob.
Oh, okay.
APWiMob conf. Let me, please, operator or Mr. Inung, please post the email for this, because actually we all the videos must be submitted through EDAS, but I think we have closed the submission, so you can send submit your presentation video using email. Okay.
So it is allowed, right? If we want if we want to present by the recorded video, but we will also present for the Q&A session.
Yes, of course.
Okay.
But you must also attend the Q&A.
We will attend for the Q&A session.
Okay, thank you.
All right.
Yes.
Okay. Thank you, Dr. Hilal.
You're welcome. Okay, any other question?
Assalamualaikum, Dr. Hilal.
Waalaikumsalam.
I'm Aslina from Malaysia. I would like to ask on my final manuscript that actually having a problem in uploading it in the EDAS, although it's already passed in the PDF Express.
Okay.
Actually, I've tried to reach your committee a few times by sending an email asking what should I do to solve the problem, because it's already produced in PDF Express. When I tried to upload it in the EDAS, there's some errors saying that some of the gutters not compatible or something. And then I couldn't do that until now. So I'm not sure how can I, solve that problem.
Okay. So regarding the final manuscript, we are aware that some authors also encountered the same issues regarding the final manuscript. So we open other type of submission. So we chair organizer, we can submit it on behalf of you. So you can, similar to the previous method for submitting your presentation video, you can send us using email. So you can using email to info@APWiMob.conf.org. Okay, we will post that on the chat, so you can you can send it immediately.
Okay, really appreciate if you could share it in the chat, and I hope that the email will get reply. Sometimes we don't have any notification to say, oh, this one is actually because I'm not sure whether my email is already get through your part or not. So
we always read the email, but maybe some of us didn't reply it, or maybe we didn't every email we always discuss it in our meeting room. So don't worry regarding that.
And one more question I want to ask regarding the presentation.
Mhm.
If let's say we only have like one presenter, is it possible if to have another member of the paper to listen to any of the presentation?
Excuse me. You you mean that in the same session there are there is more than one authors?
Yes.
Okay.
To join and
To
just
join. Okay,
listen.
it's okay. It's okay. We want to make it's okay. All of you, all the authors, you especially for online session, you can attend the session in parallel. As many as possible. If you have, let's say, you have any students you want to attend, you can also attend it because this is online. So I think we are there are so many rooms available for that. And we want to make the discussion in the session panel session to make the discussion is more active.
All right. Thank you so much on that. I think that's all for my question. Thank you.
Okay. Also the email Mr. Inung, Dr. Inung Wijayanto has already sent the email. So if you have anything for your any question, or you have some revision for your manuscript or for your video presentation videos, you can send it to that one, info@apwimob.conf. I think this one, hopefully you can see it. Okay, any other questions? So okay, I will display this. So these are the link, first day link, the second day link for the online Zoom, and for presentation schedule is this one. Okay. Any other question? Okay, I think that's it from me, from the organizer, Dr. Inong, or from the operator, Pak Bagus. Any other information that you want to share? Okay, I think there is nothing left. So I would like to say thank you for attending the technical session, and also for participating in our conference. Let's enjoy the conference. Let's discuss. Let's make some novelty, some breakthrough in our daily, in our jobs, in our profession. Okay, thank you very much. See you later.
Thank you. So.
I would like to invite Dr. Eng Danu Dwi Sanjoyo from Telkom University as moderator for our tutorial and invited speaker session. Please give a warm applause.
Assalamualaikum. Good morning, ladies and gentlemen. Yeah, it's honor for me. My name is Danu Dwi Sanjoyo from Telkom University to become your moderator for the first session of in the first day in APWiMob 2023 conference. And we arranged the first session into two parts. The first one is tutorial by Dr. Vicky Yosep Suratman, and the second part is talk by Professor Suman Latapat Tripati. So for the first part, let me introduce the speaker. Dr. Vicky Yosep Suratman was born in Jakarta, Indonesia in 1976. He received the bachelor's degree in engineering physics in 1998 and the master's degree from the School of Electrical and Informatics, Institut Teknologi Bandung, Indonesia in 2006. He was awarded the doctoral scholarship from German Academic Exchange Service, or DAAD, and got the doctor in degree from the Technische University Darmstadt, Germany in 2014. He joined Astra Microtronics Technology in Batam, Indonesia from 1998 to 2001. Then lectureships at Universitas Komputer Indonesia, or Unicom, Bandung. And in 2007, he joined the Faculty of Electrical Engineering, Telkom University, Bandung, as a faculty member. He had been the head of Department of Electrical Engineering, Telkom University in 2020 to 2023. His research interests include statistical signal processing, radar signal processing, and machine learning. Dr. Suratman is currently a member of the IEEE Signal Processing Society. He is also the chairman of the Signal Processing Society, or SPS, Indonesian chapter since 2016. So let me give applause for Dr. Suratman. Yeah, and we have about 60 minutes for this tutorial. So we arrange into two parts. Yeah, first talk and then followed by 10 minutes of question and answer. So Dr. Vicky, you have about 45 minutes. So time is yours, please. Yeah.
Action for Dr. Danu. So the previous one. Okay, so my talk entitled is radar data acquisitions and also Doppler processing. And currently I was interested in radar since 2021. Yeah, so this is some kind of part of my research also in radar signal processing. So this is actually my educational background. It has been mentioned by Dr. Danu. And I was interested, basically I learned about statistical signal processing in my doctoral degrees, and because there is some similarity between statistical signal processing and machine learning, then I was also interested in machine learning, and finally, I also interested in radar. So what comes to your mind if I said something about radar? So this is the first time that you cross your mind. It's basically two things. The first one is about, always about airplanes. So this is detections of the targets, for example. But now, because radar is ubiquitous, so nowadays radars can be implemented in several areas. For example, here you can have like vital sign monitoring, let's say for your respiration rate and also heart rates and so on. And also radar has been used for disaster recovery, for example, in locating live victims under ruins. And also we have used radar for measuring soil water contents, and also about bridge monitoring and landslide monitoring as well. And now radar also has been an alternative to use in automotive and also for human activity recognition. So mostly I work on human activity recognition for radar, using radar. So here, because then radars emerge as technologies for supporting large sectors for commerce, also on defense and security. But then there is some interest also to apply machine learning to the radar data. But the problem is that data set in radar is very unique, and sometimes it is difficult not difficult, I think, because let's say some students having difficulties in understanding about radar data acquisition because it seems different with other sensors. Yeah. So this is motivate my tutorials today. So here, for example, because radar is how come that's one-dimensional signal becomes two-dimensional, even three-dimensional signals. So for example, because signal processing is actually applied for certain of time scale in radar. So for example, for pulse compressions, it is for fast time signal process in fast time scale. And let's say MTI, this is for slow time scale and so on. So this is very specific. So to understand the radar data acquisition is very important in order to apply, let's say, machine learning for classifications in radar. So here, the outline of my talk. The first one is about radar data acquisition. This is very basic. This is a preview of radar signal processing. And then about how to organize post data, radar data. And then I continue with Doppler processing. There is some MTI, post Doppler processing, and I will give you at the end example how to apply radar data to classify human targets. So let's continue with the first one. So here we have some basic radar functions. This is in the past. You have radar for detection, whether there is a target or no targets. And then also for tracking position and tracking velocity of the targets. And usually this one is we have, sorry. So here we have detection. There is a clutter. Clutter is, you can consider clutter as a interference here and also here, but here for imaging, clutter is actually the target. So you can have some land maps using radar. But then I think all people here knows that radar works with IQ signal. This is a complex signal. So we have here, because the information usually contains in amplitude or in phase. Yeah. So here we have like IQ signal. So, yeah, this is very well known. We can have like two channels here, quadrature channels and in phase channel. So you can extract some kind of information about the phase as well, not only the amplitude, but also the phase. So here, yeah, you can represent radar data using like exponential complex because it can explain the magnitude and also the phase. Yeah. So, but actually in the implementation, you can always use with the real valued signal on. So here, the generic radar signal processing is basically a lot of processing in radar, but this is not unique and also not exhaustive because some part is used and some parts not used and so on. But we will speak about here. This is about radar data acquisition. You can follow like using beamforming if you are using arrays of radar, and you can use pulse compression just to make resolutions with low power. And also, yeah, you can say using clutter filtering, Doppler processing, and so on. You can have imaging, automatic detection for tracking or target recognition. Okay, so you have also to consider about the signal phenomenology here, because it's kind of different what you want to extract. Let's say for human movement, you can extract micro Doppler and Doppler also. So here, because radar is very, you can say it's different. It doesn't mean that it's difficult compared to other sensor, but actually radar works in several time scales. For example, here you have fast time when we speak about one pulse, and slow time when we speak about multiple pulses, and also dwell time and multiple dwell time. And applications of radar signal processing, let's say for single pulse, this is the example. The first one about the pulse compression, or communication system said this is using match filtering. And in slow time, you can have like Doppler processing, imaging, and multiple CPI detection. You can have like ambiguity resolution between Doppler frequency and range resolution as well. And you can have track filtering also. Let's see for the one pulse. This is fast time. This is called fast time. You have here because actually when we speak about pulse radar, you have several pulse transmitted. And here we have like the time periods between, which is called as here. Let's say, for example, here it's, this is one pulse and so on. After transmitted one pulse and the receiver switch to sample the data. Here you can say we have several range bins here, as we call it as cells as well. And every time we sample the data here from the receiver, we can have fast time here. And if you arrange this fast time later, it will be called as a slow time. So after you transmit, then the radar will switch to receive to data acquisition. So here, for example, as a result of one pulse, this is called fast time. So it signifies the range and also time delay, because when we transmit pulse and we receive the signal, sample the signal, echo signal. So time is related with the range, because it is a time delay related with the range of the targets, right? So this is called, we call it as the fast time sample. Yeah. So the resulting samples can be stored in digital memory. And also here we can have fast time phase history of the pulse echo radar. So here we have some resolutions in meters. This is related with the period of sampling. So this is the resolutions of the bin spacing or resolution of the range. This is related with velocity of electromagnetic wave multiplied by TS and divided by 2, because it is round trip delay. Yeah. So we call it as pulse repetition interval. This is related later with pulse repetition frequency. So how many pulse transmitted in 1 second. So it is later related with Doppler frequency or velocity of the target, maximum velocity of the target, which result non-ambiguous. So then if we arrange each fast time sample, so this one is for one pulse, this is one pulse, this is the second pulse, third pulse, and so on, we can arrange the data of the radar and we call it as pulse slow time here. So this is the fast time for one pulse, and this is slow time for several pulses. Yeah. So here we can have the same range. We call it as range bins here for the same range of the target and so on. So we can call it as coherent processing interval. You can use this one, for example, using FFT to have Doppler, to measure the velocity of the target and so on. So now we have two axes here. This is fast time axis, and this one slow time axis. Yeah. So then PRF, what is the rate of the slow time? So it is related how much is the maximum velocity of because if you take a look at here, there is two samples, two sampling frequency here. Is the sampling frequency for fast time and sampling frequency for the slow time. And Doppler processing is actually deliver according to range. Yeah, so it means that this is the sample, the frequency sampling of the sample for the slow time. So this is related with pulse repetition frequency or pulse repetition interval. So in that case, the velocity is related or proportional to the pulse repetition frequency. So this is the example of the data acquisition for fast time and slow time. Here, fast time related with range, and slow time, this is pulse number, and you can see it from here for walking people, walking person toward radars here. You can see this is the movement, and this is the power of the echo signal. So if you use array antennas, so this is more complicated because then you have to add one dimensional, which is called as a receiver channel or path center here. So we can have, this is called the radar data cube. You have pulse, you have path center for several antennas, and you have also one pulse sampled of a result of one pulse. This is called fast time, this is slow time, and this is path center. Yeah, so we have three-dimensional. But then even though we use only one antenna or one receiver, we can also have to generate three-dimensional signal if you include Doppler frequency. So we have Doppler frequency, we have range, and also we have time. Yeah, so we can generate three-dimensional signal from one-dimensional signal of the radar. So here, for example, this is the results of three-dimensional data cube. For example, we have range here as a sample. This is range bins related with the range of the target. Here you have pulse number. So it means that here you have the same range, and also this is for fast time, and then this is the pace center. You can apply it, for example, using moving target indicator to remove some clutters, and also pulse compression to increase resolutions. And also here you have a target Doppler frequency, or even for beam forming if you use array subsensor. So this is for a model for understanding most digital signal processing for radar operations. Okay, so this is the last terms for data acquisition in radar. So this one is for rotating radar. Actually, this is called as dwell time. This is dwell time is defined as how long that the target is receive beam from the antenna. So this is, for example, we have beam theta 3, and you can you can measure the dwell time using this formula. So this is a rotation per minutes, and this is the beam width, and this is 60 because we measure in seconds. Yeah, and this is very easy to calculate. So how about frequency modulated continuous wave? So basically, pulse wave, in terms of acquisitions of the data, you can use the same theory, but then the difference is that when we use frequency modulated continuous wave, the time marking is not from the pulse. The time marking is from the difference between received frequency and transmitted frequency. So we call it as bit frequency. So bit frequency is basically related with the range of the target or the delay. Yeah, here you can have the formula. If this one is the time swept, and this one is frequency bandwidth, and you can calculate range based on the time swept, the velocity of the electromagnetic wave, and you can have the bandwidth, and FB is bit frequency that you can get from FFT from the signal reception. So this is, you can use like frequency bin from the result of the FFT here. So because object distance is related with the bit frequency, then afterwards, after the FFT, overall is the same processing or the same terms when you use pulse radar data as well. So let's have a look at Doppler processing here. This is very simple concept. I think all of you knows about the FFT fast Fourier transform. So it is actually what we receive is not only the echo signal from the target, but also echo signal from the surrounding. But the difference is that the target having velocity, so it means you have Doppler frequency there, but clutters mostly static, so it will result in zero frequency of Doppler. Yeah. So the purpose itself is to suppress clutter, and suppress clutter returns and to enable detection target in presence of significant clutters. For example, this is using this the very basic concept. When you have several targets here, there are 4 targets, for example, it is easy to distinguish in the range bin of 4 and 50. This one is 18. It is because it is moving away from the radar, so we have received negative frequency of Doppler. But then difficulties come when we only take the advantage of the time domain signal. But using Doppler frequency, even though this is in the same range, but with different, whether moving away or move toward the radar, you can distinguish from Doppler frequency. Moving away, it means that the Doppler frequency negative, but then move towards the radar, the Doppler frequency is positive. So even though it's the same range, you can always have different Doppler frequency then. But then the clutter contains mostly on around zero frequency of the Doppler. So it is easy, yeah. So here the result, for example, if you want to describe the bin 11, so here we have, this is moving target, and this one moving target as well, but they have different Doppler frequency, and here we have clutter. So how to filter out the clutter is actually using high pass filter. So this is the first option for Doppler processing is actually using moving target indicator or MTI. So it is processed entirely in time domain. So it cannot reveal any information about the target speed. It can only remove clutter. But then you can also use in pulse Doppler processing when you want to measure also not only the target, but also not only the positions of the target, but also the speed of the target. So here, I think what we have so far, we have here slow time. This is number of pulse, and this is fast time. This is one pulse. Yeah, one pulse. Signal reception is sample using for one pulse, and this is several pulses. If you arrange, it becomes some kind of matrix here, 2-dimensional matrix formed from a series of M pulses, for example. So here we can apply digital filtering for each target. So we have here digital filtering for each range bin. So you can have, then you can detect not only the range, but also the velocity when you applied Doppler processing. But let's have a look for moving target indicator. So the aim is actually to remove clutter. Here we have, yeah, the concept is very easy. You can have only high pass filter. So this is before filtering, this is clutter. You can have high pass filtering just to remove clutter centered at 0 Doppler frequency. And this is after filtering. What remains is target signal and noises. Yeah. So this is very simple, but you have to apply for each range bin here. So this is MTI filter, but then after MTI filter, you can apply some kind of detection, whether it is larger than certain threshold or lower than a certain threshold, in order to conclude whether there is a target or no target. Yeah. Okay, so actually for MTIs, you only apply FIR filter, finite impulse response filter. You can use like two-push canceller, because I mean, it is very easy logically when static signal arrive here from cluster, you just subtract the previous sample to the current sample, because it is static, so it will, I mean, it removes the cluster itself, but then moving target will not, because it changed with time. Yeah. So this is the logical explanation for why this is very simple filter. This is first order of the filter, but then you can also like a three-push canceller here. I mean, this is from past sample and also yeah, past sample. Second, this is the first delay and second delay. This is very easy. This is a basic form of FIR filter, and this is first order of FIR filter, and this is the second order of FIR filter. Okay, so this is the result, because discrete time signal, you know, this is the periodic of the frequency, so this is basically high pass filter as well, and this is high pass filter, both of them, but this is this is steeper than this one. Yeah, because you use the second order, and this one is only first order of the filter. So this is very basic signal processing, FIR filter, but we call it as moving target indicator in radar. Yeah, this is to remove clutter, but you cannot conclude anything about the velocity of the target or Doppler frequency from the MTI. Okay. So then this is the result of when we have clutter here. And this is the result of two-push canceller output here, the black one, and this one, the result of three-push canceller output. So you can reduce the clutter, so you can have SNR, higher SNR by using two-push canceller and also three-push canceller. Okay, so that's not, like I told you before, and MTI filtering, we cannot estimate Doppler frequency at which the target energy causing detections to occur. And also then the second major, you can call it as push Doppler processing. So you can conclude what is the velocity of the target. Okay. So we can apply Doppler processing in slow time domain. Yeah. Okay. So this is what we have. So you can have, this is, sorry. This is fast time. This is slow time. Then you can apply the FFT for each ring spin here. So later you can have a ring Doppler matrix. Yeah. For each range, you can have like the frequencies of the target here. So we call it as ring Doppler matrix. Yeah. So you can use sample, which that does not have to be equal with M. You can have like FFT size, K FFT size, which is higher than number of pulls. It's fine. Okay. So yeah, then you can have like a filter bank or something. So here we can have, because it is in Doppler domain, frequency domain, then you can have target with certain velocity moving away from the radar or moving toward the radar. Yeah. So if the sample cross the threshold, so then whether the target is detected or not detected. So now the signal after this processing. So it will not be dominated by the clutter of the signal. It's only from the target echo. Yeah. So this is very simple. Yeah. So then I will give you some example. This is very easy example actually. So here, this is about what we are doing right now to classify or human activity recognition, because yeah, I mean, this one has been done by several researchers all over the world, but I think this is very interesting because I mean, human movement is very unique. You can result not only from the translational movement of human, because there is some micro movement from your torso or from your limbs and so on. So it can result as micro Doppler signatures. Yeah. So translational movement, it results in Doppler, but then micro movement from parts of your body is actually result in micro Doppler. Even it can be used for gait analysis in radar, yeah, in human activity recognition. So we can apply the things that we have done before for data acquisition, radar data acquisitions. Here you can have like, sorry. So here we have fast time and slow time, as I mentioned before. And then you can remove like clutter removal and also DC component removal, because from okay, so because analog to digital conversions, it's I'm using, for example, here we are using 12-bit analog to digital conversion, so it ranges between 0 until 4095. So this is DC. If you have to remove it, you have to remove DC, and you have to normalize into some, let's say, from maximum voltage is 3.3 for our radar, and then you can remove the DC because actually it will appears as the zero frequency. So we have to remove DC component, and then you can use FFT directly for certain processing interval, but also you can use short time Fourier transform, because FFT cannot explain which frequency happens in certain time, but using short time Fourier transform, you can reveal that information. But not only for, this is linear time frequency analysis. You can apply also like quadratic time frequency analysis, for example, using Wigner-Villay distribution and so on. Then you can apply it to reveal some micro Doppler signature from human body. Yeah. So in that case, when you apply short time Fourier transform, then you can crop the data here. Then finally, you can fed to the machine learning algorithm just to classify whether the target is standing, walking, crawling, or sitting. So you can use radar, exactly. So you can use radar as complementary when you want to take the advantage of multimodal activity recognition. I mean, camera has been used as well, and PIR sensor also can be used for human activity recognition, but then radar also. And radar can preserve privacy compared to other sensors. For example, for fall detections, you can use radar in bathroom. You cannot use camera because then camera doesn't preserve any privacy there. But when you use radar, it can preserve privacy. So what makes it interesting as well here, let's not again. Okay, when you use the mati lagi. Sorry. Okay, so what's interesting to explore is that if you are here using camera, for example, like a convolutional neural network, because CNN works based on visual cortex. So I mean, CNS has been considered as the very best one for a machine learning algorithm, one of the best, I guess. But it is for image, I mean, from optical sensors. But then how about when we are using radar? Because radar, it is not optical image here. This is as the result, for example, from time frequency analysis, whether CNN is a very base way to do machine learning or no, or how to represent radar data, the best one, in order to have a very high accuracy machine learning algorithm, and also you have to consider about the computational time, because for example, if you use like using three-dimensional data, time, frequency, and range, so it will be very huge data. So how to make our machine learning algorithm very fast as well, but also maintain high accuracy. But until now, in radar community, I guess we don't have anything to say about what is the best way to represent data before this is fed to the machine learning algorithm in order to make some classifications, for example. So I think one of this work also have been presented in our previous APWiMob, but this is about how to identify, how to time mark with the transition, let's say from sitting to standing or standing to walking and so on. Yeah, this is not only for classification, this is also for, let's say, the transition, how to detect where there is change from standing to sitting and so on. Yeah. So here, for example, this is using a post-Doppler radar hardware. This range bins. This is from fast time. This is from slow time. But if you applied a time frequency representation for each range, so you can have here slow time as a function of frequency for each range. So now you have three-dimensional data. This is for number of pulse. This one is for the frequency. This is for the range. Yeah, this is the fast time. Yeah, so now you have three-dimensional data in order to classify by using certain algorithm from machine learning. Okay, so you can apply it also not only for using FFT. You can have several time frequency analysis, quadratic time frequency analysis, or linear time frequency analysis to reveal some unique features here. Let's say from walking, what is the unique one, and from sitting, what is the unique micro-Doppler signature, or even for someone like using gait analysis, you can reveal who is walking. Yeah, the person who is walking also can be identified. Yeah. And this is what we have done. This is using URAD data. This is not very good radar actually for human activity recognition. So we need more higher resolution radar. So this one, let's say, for example, we have frame here. This is fast time as before. This is slow time. Then you can apply the FFT because this is FMC, frequency modulated continuous waves. So you have to apply the FFT to get the target, the range bin, and this one is slow time. Then you can apply the STFT here to have Doppler frequency as a function of time. So then you can have here Doppler frequency as a function of time for each range. Yeah. Okay, this is the same with the previous one where we can get three-dimensional data. So here some results. It is not very good actually. So this is from the resolution is not very good. So this is standing. This is still best raw data. Yeah, this is not. Yeah, you can. I think there's kind of difference here visually from standing, walking, crawling, and sitting, and so on. But after processing, you can see it. This is from standing. And this is walking, sitting, and crawling. Even though this is not so very good, I mean, results visually, but then we can apply it also afterwards. And we can achieve like 99% of accuracy to classify standing, walking, sitting, and crawling. So, okay, I would like to make some, I mean, this is the last slide, I guess. This is radar also has been implemented in several areas. Let's say for security, you can say radar can be used for people counting and active shooter recognition as well. And we have done also some work in vital sign monitoring for respiration rate, but it is very close range, 1 meters or smaller. Yeah, it is very difficult to apply it for a very long range, let's say more than 3 meters and so on. And you can also apply radar for gate analysis, fall detections, and also you can like activity where there is some activities, especially for elderly. Yeah, you can apply radar to monitor their activities, because I mean nowadays like a lot of elder want to live alone, yeah, with his or her couple. So this is very important to know whether something happens to the people. So we can use radar, for example, for fall detections, because majority of fall happens in bathroom. Yeah, so you can apply radar to monitor fall detection. This is what we are doing right now for bachelor degree. Actually, I have some result for fall detection using capstone in capstone design in Telkom University, and they have applied radar for fall detections. But we have some difficulties because we still have false alarm rate, which is very high. We can apply it online real time, but we still have false alarm, which still very high. So this is the challenge as well for our future works in fall detections, especially for real-time implementations, because most of literatures only talk about fall detections, but in theoretical level, but not many literature talk about the real implementations of the fall detection itself. Even though, yeah, we have several, but then we try to do that, and yes, we get some result for that one. And also you can apply, this is, let's say for smart environment, you can use radar for, yeah, I mean, it's been a long time ago to apply radar in automotive and so on. Now we can have, I mean, we have some alternative using LiDAR or radar for automotive applications. Okay, you can use radar also for human-computer interaction to represent for, let's say, sign using your hand and so on. And okay, so probably there is some kind of features research that you can do in radar. For example, how the best way to represent radar data before you applied some machine learning algorithm, because yeah, I mean, it is like I told before, it is different data representation when you are using optical image sensor, using camera and radar. Is there any best way to represent data using radar compared to conventional algorithm using, let's say, convolutional neural network? But also, which might be interesting as well in terms of because radar is complex signal. So is there any kind of machine learning algorithms that can work using complex machine learning algorithms, for example? Because we usually use real value weight function, let's say, but how to apply complex value weight functions in machine learning algorithms. That might be interesting as well to dig into in the applications of radar signal processing. Okay, this one is the last part of my tutorial. I hope that this is this is very simple tutorials, but I hope that you can have some things for you to take, or probably if you are interested in research in radar, so we can have some kind of collaborations. Okay, thank you very much.
Yeah, please give applause for Dr. Vicky Yosef Suratman. Thank you, Dr. Vicky, and it's very interesting topic. So let's go to the Q&A session. So please, for all participants who have any question for Dr. Vicky, please raise your hand. Any question?
Thank you very much, Pak Danu, and also Dr. Vicky for nice tutorial this morning. Actually, I have 4 questions, but I try to ask 2 first. If no other question, I will ask the next. So the first, would you please tell us what is the main problem of radar data acquisition, such that yeah, we need this technology. We need the solution from which you have explained. So that is the first. And then the second is that usually we also understand that for the stealth flight, that they can absorb the signal of the radar. It is not possible to detect that flight, for example. And then how your technique can solve this problem for the stealth flight. For example, we want to detect the flight or someone with the absorption of the signal. So this the question number 2. Okay, I just the next. So what is the bandwidth of your signal for the radar? It is a narrow band or it is broadband? And the third and the last is what is the FFT size you are using for the STFT? And then how that size will impact to the quality of the image? Yeah, thank you very much.
Okay, good. So the first question is related with what is the problem with the data acquisitions? So there is no problem with data acquisition actually. So the problem is that how to represent radar data, for example, because now I'm interested in to apply a machine learning algorithm to the radar data, but the problem is how to represent the best way so we can have a very good performance of machine learning algorithms. But probably this is in radar community, it is already known that there is some kind of a trade-off. For example, you need some very fast acquisitions because it is related with the let's say, for example, in a pulse radar, this is very narrow of the signal. It results in very high bandwidth in frequency domain. But then the problem with pulse radar is that you have the average power is very small when you make it very narrow width of the pulse, right? So no, not narrow pulse in time domain. So, but then the power should be very high, right? I think it is already well known in radar as well. But then if you increase your power, you cannot increase power very, very high. So that's result in a problem because when you want to attain resolutions in range, so the problem is that you have to make it very narrow width of the signal. But then the problem is that the power average is very low. But then come with the frequency modulated continuous wave. Or you can have like to apply some pulse compressions for that one using match filter and so on. But then when you want to use low power radar, then you can use frequency modulated continuous wave. Yeah, let's say using FMCW and so on. But FMCW having a problem with the resolution for range, because it is very difficult to make a sweep frequency which is very consistent. For wider sweep frequency, it's very difficult. But then resolutions of the range is not very good enough. So then it came with the step frequency and so on. Yeah. And also what interested for radar than other sensors, you can use radar through the walls. You can detect someone behind the wall. So you cannot use that one using camera and so on. So that's what we want to do also in the future for human activity recognition behind the wall. So, and the second question is related with also, okay. I mean, that one is very related to electromagnetic theory. So I have no clue about that one, how to detect. Probably, I don't know, with quantum quantum radar. Yeah, okay. So yeah, I mean, this is very, so how to make it, yeah, stealth plane you can detect, but I don't think you see, I don't know, actually. I have no capability to explain about that one because this is related to electromagnetic theory. I don't know, actually. And the bandwidth of the signal is basically in megahertz, 200 megahertz that we use for URAD. 200 megahertz is very wide, yeah, for radar, yeah. So, and also this is FMCW radar using URAD, 24 gigahertz for the carrier frequency, and megahertz and 200 megahertz for the width. And for the, I think this one you can see it from this time scale. Bisa lihat nggak? Kenapa nggak bisa? Okay, so so in here we are using URAD, 24 gigahertz carrier frequency. The FFT size is 64, only 64, yeah. So this one is have 50 samples for the range bin, and we apply the FFT using, for STFT, we use 16 and 32 for STFT. And what makes it interesting, I think one of my students try to explore the effect of the window size for STFT. But it is very simple, a very simple method using T-student test, and there is no effect for the size of the STFT. But I think we have to dig it more because I'm not too sure whether there is no effect. But until now, what we have observed that the window size of the STFT does not affect the result of F1 score. But actually in signal processing, when we speak about the window size, it is related with the transition region, right? Whether the main lobe compared to the side lobe and so on. But then if we further speak about the effect of the window size for the machine learning accuracy, what we have until now is that there is no effect from the window size. I still don't know. I'm not so sure yet, but it is only using t-student test, because t-student tests have some kind of assumption that the distribution is Gaussian, right? But I don't know what is the distribution of our result, but then yeah, but it makes me interesting also in this case, because I mean, probably the symptoms is different when we speak about signal processing and when we speak about the pre-processing in radar data to be applied by using machine learning. Probably have different results. So even in a book that I read, that the author said that probably pre-processing not needed in machine learning, because probably the signature of people walking, for example, and people sitting and so on can be exploited directly from the raw data of the radar without any processing. Yeah, but we still don't know. So I think this is very important also subject to be dig into in our research. Okay. So when you are doing the FDFT, are you using the upper something? No. Okay, so for example, yeah, I mean, of course, there's some padding for the zero padding for the, but also we applied like Kaiser window using some parameter beta, because Kaiser window is very I mean, you can approach some windows by using Kaiser window. There is some parameter, we call it as beta, and then we can change the shape of the window itself. So of course, there's some padding of zero. Okay.
Yeah, thank you very much for Dr. Khairul, and also thank you very much for Dr. Vicky Yosef Suratman for your talk. It's very interesting topics, but unfortunately we have our time is out for the first part. So thank you, Dr. Vicky.
Okay, thank you very much. Yep. Thank you very much, everyone.
Please give applause for Dr. Vicky. And for the second part of the first session, we will have a talk by Professor Dr. Suman Lata Tripathi. So is Dr. Suman already joined? So Professor Suman, can you hear my voice? Yeah, Professor Suman, can you hear my voice?
Yes.
Yeah, thank you. Yeah. We will start for the second part for the first session. So I will introduce first for your CV, and then we go to the talk. Yeah. So let me introduce first. Professor Dr. Suman Lata Tripathi is working as professor in Lovely Professional University with more than 21 years of experience in academic and research. She has completed her PhD in area of microelectronics and VLSI design from MNIT Allahabad. She did her MTech in electronic engineering from UP Technical University, Lucknow, and BTech in electrical engineering from Purvakal University, Jaunpur. She is also a remote postdoc researcher at Nottingham Trent University, London, UK in year 2022. She has published more than 104 research papers in referred Springer, Elsevier, IEEE, Wiley, and IOP Science Journals, conference proceeding, and ebooks. She has also published 13 Indian patents and 4 copyright. She has worked as a session chair, conference steering committee member, editorial board member, and peer reviewer in international or national IEEE, Springer, Wiley, etc. for journal and conference. She has received the Research Excellence Award in 2019 and Research Appreciation Award in 2020, 2021 at Lovely Professional University, India. She is recipient of IGEN Women's for Green Technology Women's Achievers Award on International Women's Day in 2023. She has also received funded project from SERB DST under the scheme TARE in the area of microelectronic devices. She has edited and authored more than 19 books in different areas of electronics and electrical engineering. She is associated for editing work with top publisher like Elsevier, CRC Taylor and Francis, Wiley IEEE, SP Wiley, Nova Science, and Apple Academic Press, etc. She is also working as book series editor in CRC Press, Wiley Scrivener, and conference series editor for CRC Press, Taylor and Francis. She is serving as academic editor of several journals from Hindawi and special issue guest editor for MDPI journal. She is associated as senior member IEEE, fellow IETE, and life member ISC, and is continuously involved in different professional activities along with academic work. Her area of expertise includes microelectronics device modeling and characterization, low power VLSI circuit design, VLSI design of testing, and advanced FET design for IoT, embedded system design, reconfigurable architecture with FPGAs and biomedical application, etc. So please welcome Professor Sumanlata Tripathi and via online. Yeah. And Professor Suman,
thank you so much.
Yeah, in total we have about 55 minutes. So for talk you have 45, and then we go to the second minutes of Q&A.
Yeah, sure. Thank you so much.
Yeah, so time is yours, please. Please give applause for Professor Suman.
Okay. So thank you all. I welcome to all participants who have joined this session. And I'm very thankful to Dr. Vajayantu for inviting me for this keynote session. And it's a great privilege for me. And since we are already in collaboration with Tel-U University for PhD student exchange program, so this will be a great opportunity. In the same context, we are increasing the activity between two universities. So let me share my screen for my today's topic of discussion. So my topic of discussion is design of high performance multi-channel filter for biomedical application. So basically it's a topic related to transistor design, means the basic component of any electronic circuit or integrated circuit. So how to design any, first of all, I'll discuss how to design a transistor, which are not conventional one. In terms of performance, they are having much better performance if we compare it with the conventional one. And then later on, the designing of the same transistor for any application like biomedical as biosensor. So if we talk about the transistor design, so first we need to think about why different advanced MOSFETs are required. So major reason behind that is scaling down of transistors dimension. Because as we know, the applications are increasing day by day. So one particular MOSFET need to be reduced in terms of dimensions as well as if voltage remains same, then accordingly the voltage scaling and other parameter scaling will be required. So if we reduce MOSFET dimension, then what will happen? Accordingly, we need to scale down the voltage and because we are scaling down the voltage, so threshold voltage will be scaled down at the same time. But when the voltage, supply voltage is very less than 1 volt, then in that case, this will become comparable to the gate voltage. So threshold voltage required, it will be comparable to the gate voltage that will create different kinds of effects. So when we scale down the transistor, the performance degrades when channel is very small. Or we can say that the depletion, if the depletion is in width found over here, will be comparable to the channel length. If the depletion region width will be comparable to the channel length, then we can say that the device is short. And in that case, the effect of short channel effects will be more common, and they will degrade the device performance. Then there will be some advanced MOSFET architecture came into the picture, in which the important one is multiple gate MOSFET. So as you can see here in the diagram, there is only one gate, and which is conventional one, and that controls the channel region, and finally it controls the drain current. And here I can see that another transistor where source drain are almost same in nature and channel, but we have two gates over here, and that gate can be parallel to each other, one after the other. That will be the case of symmetrical only. And if this one is not overlapping each other, it means that is a case of asymmetrical MOSFET. So there, in both the cases, we are having how many gates? Two gates, one at top and other at bottom. So what are the advantages of having multiple gates? The dimension remains same. The device dimension, if dimensions are same, then we have two gates, so that will have more control over the channel. Here, the channel is controlled through the top. So if any changes is happening over here, so that is not much controlled by the, means this is called bulk region. So bulk region will, this gate have less control over the bulk region. So that's why multiple gate concepts came into the picture, that has more control over the channel, because both the sides, it has gate both the sides. And also we are also increasing the current, drain current. If two gates, then twofold of actual drain current. And if three gates, then so there will be a multiplying factor of drain current depending upon the number of gates. So increasing gates, we are having improvement in drain current, and then the speed of circuit, means the logic transfer, the delay will be less, so more speed. So that they are useful, multiple gate MOSFETs are useful in improving the device speed as well as they are having more control over the channel. So when we reduce the dimension, means with this channel length, suppose we are reducing all the dimension by factor S, which is called scaling factor. So scaling factor normally lies between 1.2 to 1.5. So if we are going to reduce the dimension, so accordingly your threshold voltage and gate voltage will be reduced. And then we can see when we talk about current, so current will also be accordingly reduced. But if we talk about double gate, so if we compare it with single gate, so this will have comparatively more current and more speed along with the control of the channel region. So any kind of variation in threshold voltage of transistor, which is called VT, will be less in comparison to comparative conventional one, because here the electric field produced by this drain over the channel will be more. So when we say that MOSFET is ideal, if the gate will have full control on the channel design. But anyhow, if this drain field is going to affect the channel electric field, then there will be different kinds of short channel effect, like variation in threshold voltage and variation in drain current will happen. So that's why multi-gate concept came into the picture. So as per my topic, I talked about FinFET. So FinFET is another example of multiple gate MOSFET, where MOSFET can be in form of double gate as well as triple gate format. So what I said, as we increase the number of gates, the control of gate will increase over the channel. And also FinFET is a kind of vertical channel MOSFET. So vertical channel MOSFET has advantage over the planar one. So planar one, so I have shown you the example of planar one. So here I'm talking about the vertical channel. So channel is vertical over here. So we can place, what are the disadvantage of this, the multiple gate in the double gate MOSFET. So here in planar, this is example of planar one. So here the disadvantage is of it is designing. Okay, so the disadvantage of it is designing a back gate. So designing a back gate inside the bulb is difficult if we have planar MOSFET. So that's why this architecture came into the picture, which is channel where the channel is vertical and we can place two side gates, like here two side gates and one top gate. So that is called FinFET because it is in fin shape. And here I said that here we have two format, double gate as well as triple gate. So if the insulating region present over here, the insulating region present over here will be thicker. So this gate will have less effect. So then only two side gates will be functioning. And if this thickness of this insulating region will be similar to the thickness of side layers, then it will be in format of triple gate. So as we are going to increase the gate, the increase on increased control on the channel region along with the increase in drain current, if even with the same dimension, if we compare it with the conventional MOSFET. Then FinFET only can be multi-channel FinFET or multi-fin FinFET. So this I considered as fin of like here this one is fin of this FinFET or channel. Fin means here channel. Fin here is compared to the channel. So channel region and gate is placed around this pin. So if number of pins are going to increase, so these are your multiple channel. Now multiple channel can be placed like this, or it can be placed in stack also. So here you can see this diagram and this diagram, there is difference. Here the channel, this is again a kind of, you know, fusion of this FinFET and planar MOSFET. So it has properties like planar MOSFET along with this in shape of fin. So multiple by adding stack of channel. So it is similar. It's something called hybrid between FinFET and planar MOSFET. So here I covered mainly different kinds of transistor architecture, which are now part of several ICs. Some products are already available on FinFET, like Samsung mobiles, they are using FinFET technologies, and many other memory design, they utilizes FinFET technology. Now, what are the performance parameters that are important to that here? So the major performance parameter, here we talk about threshold voltage. Means the minimum voltage required to make your transistor on, and off state current when the transistor is off, is in off state. We are not applying a suitable voltage to make it on. In that condition, how much current flowing, which is called IO. And drain induced barrier loading. So what I said, when the transistor, if we talk about the transistor source, gate, source, drain, and gate. So this is your channel region. So the effect of drain field in the channel region, the effect of drain field in the channel region is basically defined in terms of a parameter, which is called drain induced barrier loading. So drain induced barrier loading basically is the gives relationship between change in gate voltage, how much variation in gate to source voltage with respect to the variation in drain voltage, drain to source voltage, which is this gate to source voltage is nothing, but this is going to affect your threshold voltage of device. Okay. So here you can see sub-threshold slope. This is another parameter which is important, and it decides the slope of the curve when we plot a curve between drain current ID and gate voltage. So we have a characteristic in off state, it has very less current when the threshold voltage is less, when the gate voltage is less than threshold voltage, G is less than VT, and it increases with the increase in different. So this one is a curve where the gate voltage is higher than threshold voltage, and then we can have this region that when the voltage gate voltage is less than threshold voltage, then we have a curve like this with the increase in gate voltage, there is change in current. So slope of this curve is going to decide the performance of device. The switching from off state to on state means a considerable current which can make the device on, or we can say a current which is desired to make device in on condition. So how much faster this switching from off to on state is basically governed through this region, which is called sub-threshold region. So sub-threshold, if this slope will be higher, like here, if this slope will be higher, then the switching performance will be better. So if we compare with shorter device with longer device, so longer device will have sharper characteristic than shorter device. So how to improve the performance? That is the design, one of the design parameters, how to improve this slope. And how this slope is expressed, it is basically expressed in terms of gate voltage variation in gate voltage with respect to the variation in logarithmic value of drain parameter. if we are going to plot the log scale drain current on log scale, and the limit on it is, if we talk about the ideal value of it is 60 millivolt per volt per decade, means for 1 decade change in on logarithmic scale, the value in VGS change will be 60 millivolts. So if your value is near about this or less than this will be a suitable case, but not too much less, because that further affect other performances. So if the value is near about this 60 millivolt per volt, that will be a suitable. Another performance parameter which is based on when we are going to utilize those devices like the designing MOSFET, and we are going to use that for logic or any logic memory or any other application, analog application, then we need to analyze certain circuit-based parameters like power consumption and power delay product. So these are our input before the start of designing MOSFET. Then how to do this kind of design and simulation before your fabrication of same device? So one of the important tools is TCAD, technology-based computer design. So here we talk about technology whenever we talk about backend design. So it works on certain technology. Technology means the minimum feature size of transistor. So here, basically, what we can do through this tool, we can design our device through draw. We can also design our device through coding. So there is some scripting language for such kind of design and simulation. And after doing this, we can simulate our device and get the different performance of the transistor, whichever is model. And here different kinds of model files are there. The basic one is the drift and diffusion model. And the software where I have designed this one is Visual TCAD, which you can find on this link. So 3D device simulation for FinFET. So what I said, FinFET is something which is vertical channel, and gate is around this channel, all around this channel region. And if this insulating region here between the channel and gate. So all the sides in insulating region are the same thickness, then it will be into the tri-gate MOSFET, tri-gate FinFET. And if this thickness will be bigger than outside thickness, then it will be double gate, two-sided gates. And all these gates are connected, so that is the advantage of it, that we need not too much bother about how much value to give on front gate and how much value to give on back gate, because all these are connected, so a single voltage is sufficient for on this to apply. Okay, and the advantage of such kind of architecture that we can go beyond 45 mm technology node, means if we talk about up to 7 mm MOSFETs are available. Model files of 7 mm are available with this tool, and products are also available of 7 mm technology. So that is the advantage of it, that we can further pack more and more transistors with such kind of technology, along with the improvement in performance. So here the designed FinFET on the TCAD. So you can see here there are 3 gates which are covering your channel region and going to control the channel region. So here if we compare it with the MOS, if we compare different kinds of FinFET itself can be of channel region, can be of silicon, means all source and drain bulk region can be of silicon. Or there are certain literature that where this film material can be of different, there can be a some hybrid semiconductor like SiGe, some some component of G and some component of Si, mole fraction of Si and G with the fixed value of mole fraction. We can design heterojunction, which is mentioned over here in this diagram. So heterojunction is when different materials are used with different doping, same doping concentration, either material is different or it is with different doping. So you can see here, like if we further change different kind of material like one of them SiGe, so the curve is going sharper. So what our aim? Our aim is to make this curve sharper so that to get better switching performance. So the slope of this curve is going to decide the performance of device. And here also we can see this is the cross-sectional view of film where this W film and H film is important parameter while designing. And overall effective channel length, if we talk about effective channel length, so how much effective channel length is 2 times H film. H film means height of film plus W film. So we can see here the effective, although the dimension is same, but effective channel length is increased in the film bed, and that's why you can say the effective channel width will be increased, so the overall current will be improved in any film bed. And further, you can optimize the performance with the use of heterojunction architecture or multi-fin architecture. I've shown you multi-channel stack architecture. Like here, one design which is available, design which is done with 10 nm technology. The basic channel length. We talk about the channel length. So here, gate length is shorter than channel length. So this is called underlap and overlap. So here 10 nm feature, here this 10 makes the size of length between source and drain. So if we talk about this kind of device, so what about the other parameters? So here we give channel length 10 nm, then gate length here 6 nm, and drain source length is 10.5. Effective oxide thickness is 2.8 nm from all the sides of film. If we talk about where this uniform means this tri-gate format. Okay, and channel doping is kept low, comparatively low than source and drain. So channel, it's 1 into 10 to the power 15, and for the source drain region, it is higher than channel region, which is 1 into 10 to the power 18. So here it has been compared for different gate voltage, 0.05, 0.1, and for different drain voltage, for different drain current, for different drain voltages. This the response of drain current with respect to gate voltage for different drain voltage. So normally, what I said that gate voltage will have more control on the channel electric field in comparison to drain, but definitely because the devices are very going to design at lower dimensions, so drain field will also take the channel region. So here you can see there are variations at different voltage. Like here, there are 3 curves. So although in sub-threshold region, you can see here, there is small variation in some threshold region. Yes, there are some variation in on current because we are going to increase BTS. So some value, so the value of drain current is slightly different and on different drain voltages. It means there are some effect of drain electric field on the channel reason. So, but yes, because this is filtered, even at 10 mm technology, we are getting ideal performance because this one is almost similar in nature with a small variation. And the on-off current ratio obtained over here is 4.34 into 10 to the power 8, which is much higher. So any value which is higher than 10 to the power 8, if we compare on and off current ratio, so we can observe the fast switching process in the device. When we come, so here this comparison is shown with respect to 22 mm filter. Here it is, if we compare 10 mm, so although here 22 mm filter diagram is not available, it is showing better performance than 10 mm than 22 mm filter device. So here output characteristic means drain current versus gate. Previous characteristic was between drain current and gate voltage, and this characteristic is between drain current and drain voltage. So how? So what I said that drain voltage will have less effect on drain current. So you can see here in this small voltage, at this small voltage, current is very less, but after having some minimum drain voltage, it is going constant. So with respect to drain, it is going constant. So if we are going to design our device for any analog application, this will be a suitable characteristic because for that we need this flat. Okay, we need this flat, and that will be suitable if they are going for amplification purpose or similar kind of devices. So you can see here the voltage has been varied between 0 to 1.2 for drain, and for this we are current very less at smaller drain voltages, and with small change in drain voltage we are getting output current 10 from -5, and here it is very less. Okay, so this is we are getting input transfer characteristic between drain current and gate voltage, and then output characteristic between output current and output voltage, which is an ideal, which are in ideal nature. And then if we talk about the process, here we can further analyze our device for different process parameters, like temperature effect, variation in channel length. Anyhow, suppose due to some fabrication defects, there are some variation, very small, minute variation in dimension. How much will be the effect on the device performance? If there are variation in doping, oxide thickness, like here, the oxide region under this one, oxide region under the gate, this is gate, and this is your fill region. So because this is very small, near about 2 mm thickness, so if this region thickness is going to vary because of fabrication defect, so how it will affect the performance. So this is all about the performance analysis of particular device with different parameters like temperature variations, because if device is performing at room temperatures, that same device will perform similar behavior on higher temperature or lower temperature, because the device is going to be utilized in different geographical applications. So the effect on device performance should not be there because of the variation in temperature. So these analysis will be done with the variation in temperature or variation for designing same device at different length by varying doping concentration or channel region or source drain region. So doping basically we use to increase the conductivity of conductor material. So variation in channel region, addition of impurity atom in channel region or source drain region is basically controlled over this parameter. Then oxide thickness. So oxide thickness, there can be different type of oxide material. We can use different kind of oxide material apart from SiO2. We can vary the material or we can control this dielectric oxide region either by varying oxide thickness or we can vary the dielectric properties by varying the materials. So actually device design is nothing but it's optimization between different dimension and operating condition along with the materials used for particular region. So we can replace SiO2 with different oxide regions like oxide with different K values and with different K values. Then performance parameter with the variation where so you can performance characteristic of 10 nm FinFET with variation in channel length. So with different channel length, here this one is for 10 nm and this is for 22 nm channel length. And here the performance, you can see the performance for 10 nm threshold voltage variation and sub-threshold slope variation. This is something on current ratio. And gate capacitance. Capacitance is also going to affect the switching properties. Transconductance with improved transconductance, even with 10 nm FinFET. And DIDL, drain induced barrier lowering. So the value for drain induced barrier lowering should be as much small as possible. So this is another design parameter which is important. Then performance of FinFET at different temperatures. So it is varied from 126 to -125, and you can see the variations. So although here the variations are kept very large, the nature of device, the nature of characteristics is same with different slope. So by increasing temperature, the current is going to increase. Why? Because the conductivity will increase with the increasing temperature, more increasing covalent bond, breaking up covalent bond, and so more free electrons, and then the current in off state will increase. So here actually here the variation is much large, but if you can see the variation between 27 to 77. So you can see here the variation is almost negligible between 10 to the -9 to 10 to the -11. Yes, if we vary temperature much, if temperature will be much different, then there will be large variation. So that kind of observation we can see and evaluate for the temperature. So here other performance evaluation evaluation is also shown, like how much variation in threshold voltage, how much variation in sub-threshold performance, on, off, and behavior. Then different doping levels. So here these curves are drawn for different doping levels, 21-16, 20 for channel region. So actually the doping variation is shown for channel region, and source drain region is similar in nature. So we have all the performance. So I already discussed that these are the major performance parameters which are going to decide whether devices should be able. Now let us talk about physical conditions. So I said there can be two kinds of single channel filter, and multi-channel. Single channel filter, here multiple channel filter with multiple gates over there. So here you can see 3 pins are there. Okay, so how to design this device as biosensor? So you can design with single pin also as well as multi-pin. But the basic difference here is single pin and multi-pin. Here, how to design the device for biomedical application. Topic is biomedical application. So you can see here the outside region here is under the gate. Okay, which is working like an insulator. Okay, insulator. And if we create cavity over here, anywhere, cavity over here, wherever possible, here or other side of this region or at the top. If we create cavity region over there, so the molecules present in nearby region of this may occupy this place, and that may affect this insulating region, dielectric constant K of insulating region. So actually by creating cavity, we are going to vary the dielectric properties under the gate. And you know, drain current, if we talk about drain current ID, so it is mu1 COX, single gate MOSFET, if I am talking about half mu1 COX W by L. Okay, W by L. So here, and then the GS minus VT, VDS minus VDS. So this one is expression. So here, this reason, this property is going to be affected by the variation in dielectric reason. Okay, oxide capacitance. So oxide capacitance, oxide A by heat. Okay, so this is going to be affected by the dielectric variation of this region. So if we create cavity here or anyhow, so how to do this in design? So through design, we can remove this region. We can remove this region, and after removing this region, we can virtually, we are doing the analysis virtually, so we can change, create a virtual environment that in presence of biomolecules, if biomolecules will be present with different charge or with different charge particle on the charge of the particle present in this region. So -6, -10 like that. So if the variation in charge particle present in this region, it will going to affect the electrical performance of the device. And also the presence number of molecules. So how many molecules are present? That is also going to affect the dielectric properties. So actually here the designing is basically designing, changing the behavior under the gate. Changing the behavior under the gate. So it can be single gate or it can be multi-pin or single pin. By creating cavity region under the gate, either at the bottom or at the side, anywhere, is going to affect the tree. And then now what will be the parameter of evaluation? First thing, the charge present, how much Q present on biomolecules, or how much number of biomolecules. Okay, so both are going to evaluate, both based on these input parameters, we can evaluate for drain current. So this is basically called designing of biosensor. So here for biosensor designing, it is done on 18 nm technology mode. because biosensor there is no much, we are concerned about, not much concerned about the size. Mainly we are concerned about the variation in drain current, because depending upon the number of biomolecules present and charge present on biomolecules is going to affect the drain current. So calibration of drain current is in terms of charge present on biomolecule as well as the number of biomolecules. So here that is means if that device is placed anywhere in human body or in the environment, so that can detect the presence of the size depending upon the size and shape and the charge present on it, it can result into the value of variation in the drain current. So more will be the variation in drain current. It means your device will be sensitive for such kind of biomolecules, more sensitive for such kind of biomolecules. Okay, so here this design is having this kind of parameters.
Professor Suman,
Yes.
pardon me. The talk time is 30 minutes left.
Okay, sir. Okay. So I'll just going to conclude over here. It's almost done because designing part is almost covered. What are the important parameters? So its device is already designed how to create cavity region that I told you now. Now, next part is the performance. So when the device is without cavity region and with the cavity region, so conventional FinFET. Then here the comparison between the conventional heterojunction FinFET and with different doping concentration is shown in this diagram. And then when the device with different biomolecules in cavity region. So basically this all discussion is about the biosensor and the how and their applications. So application mainly is to detect any microbiomolecules, nanobiomolecules, and we can also predict about how much charge present. So that will be helpful in many kind of disease detection, because basically the properties of body changes with the changes in the presence of charge on molecules and the size and shape of particular area. So here different materials are compared, which are similar to the natural biomolecules, and these materials are going to change the properties like permittivity of oxide, and that are going to affect the drain current. So the variation in dielectric constant is going to decide how much will be the drain current, and that can be calibrated in terms of device. Okay, so here there are different current observed with the variation in threshold voltage with different value of K. So here the variations are shown. It is changing with respect to the variation in K value.
It's already finished. Oh.
So here it is almost done. So what are our conclusions? So conclusion is to design any device which has better performance, good ion of current ratio, so that we can have good switching behavior, as well as the other performance like power consumption. If leakage current will be less, so less power consumption. So device will be have less overload on the battery backup. So if such devices are used for any logic or any other digital and analog application, that will consume less power. And also these can be designed for some as a sensor at the level of device. Not only at the device, we can design it at the level of circuit also. But here I have discussed only for the design. And here are some references where the work has been already done related to device through my lab. And basically, I covered the references which is done by my students and me. So thank you very much.
Yes, thank you very much, Professor Suman. Next, we go to Q&A session. So please, the participants, is there any question from you to for Professor Suman? Please raise your hand. Yeah, please, Dr. Khairul.
Yes. Okay. Yeah. Okay. So thank you very much, Professor Suman, for the tutorial and also the introduction about the transistor, the future of the transistor. I am Khairul Anwar, currently the director for the Advanced Intelligent Communications in Telkom University. I am working on the 5G Advanced and 6G currently. My questions are 2 points. So the first is you presented about the FinFET. And then when we look back into the APWiMob spectrum released in December 2022 or last year, so the APWiMob magazines, APWiMob Spectrum magazine, yeah. If you look at that article, so they presented the trend of the transistor until 2045. And then when you look at the FinFET positions, and the position is in 2010. And then we have the new transistor, which we call the complementary FET or CFET, which is released in 2020. And then when, okay, so that's the first point as the basic understanding of the trend of the transistor. And then when you explain that the FinFET size is the 10 nanometers, so I remember that the barrier, the atomic size barrier of the transistor is below 1 nanometer. So my first question is that, what is the difficulty of making transistor below 1 nanometer? So that's the first question. The second is that the trend of the size of the transistor is decreasing. And then the APWiMob spectrum predicted about the future of the transistor in 2045. It is exactly the golden era of Indonesia to 2045. So the interesting question in that article is that since the era of the quantum is going on, and then does the transistor at the time the transistor in 2045 support the quantum processing? So that is the second question. Okay, so thank you very much, Professor Suman.
Yeah, you are absolutely right. Now quantum processing is there in the in the researches it's going on, but still the device level transistor design device level becomes is important, because we cannot always think about the size of transistor, because some of the applications like the device is designed for satellite application or any bigger microwave level. So in that case, such kind of devices design is important. And if you talk like question here put in the chat box that and you also asked that what will be the major adverse effect by reducing the transistor size. So if you are talking about 1 nm technology node, so basically the threshold voltage will be get affected, and it will be comparable to the supply voltage, because supply voltage will be continuously reducing if we talk about constant electric field to maintain the other performance in desired range. So that is going to affect. And after a certain level, it can't be possible to reduce the size, then we need to think about the content. But yes, still there are number of applications that can be done, like even in biomedical also. Here we are comparing the drain current with the variation in the molecule present in cavity region. So if we increase cavity region size, then the current will increase. So here different kinds of applications require different kind of design parameters. So somewhere the parameters are dimensions only, somewhere the parameters are voltage, how much will be the level of voltage, required level of voltage, and some of the things will be related to like based on the conditions, operating conditions.
Is there any additional questions? No, enough. Okay, thank you very much for Dr. Khalil for the question, and also for Professor Suman for the talk and also the answer of the questions. So yeah, this is the end of the second part of the first session today. And thank you very much once again for Dr. Vicky Yosef Suratman for the first speaker, and then the second speaker is Professor Sumanlata Tripathi. So let's give applause for the our speakers. Thank you, Professor Suman, and for your time. And
thank you so much. Thank you everyone for providing me chance. Thank you once again.
Yeah, see you in the next occasion, Professor Suman. And yeah, this is the end of the first session. I would like to say thank you for all participants for your attention. And yeah, I will close this session by thank you. Yeah, I will give back to the MC.
Thank you, Dr. Engdanu Dwi Sanjoyo, for the guide of the first tutorial and invited speaker session. And once again, please give a warm applause to him. Ladies and gentlemen, before we continue to the next sessions, we are now in a lunch break or a break session. Our food stalls are ready at the restaurant on the first floor and ready at 12 o'clock. And please be note that the lunch break is about 45 minutes. We encourage you to join us again at 12:45 to continue to our second session. Please enjoy the food and your time. Thank you.
check, check 1, check 1, check 1, check, check 1, check, 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 check 1, check, 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 check 1, check, check, check 1, check, check, check 1, check.
Tes.
Check.
Tes.
Good afternoon, ladies and gentlemen. Now we return to our agenda, which is the second tutorial and invited speaker session. We would like to invite Dr. Eng Fabian Dewanta from Telkom University as moderator for our tutorial and invited speaker session. Please give a warm applause.
Okay, good afternoon, ladies and gentlemen, excellent researchers and participants here. Okay, in this afternoon session, we will have two lecture, two tutorials and invited speakers. The first tutorial is presented by Dr. Asep Swendi. The topic is about the IoT devices and connection, and the second is about the 5G and 6G, and also including the quantum technology, presented by Dr. Khairul Anwar. Okay, let's move to the first tutorial that is presented by Dr. Asep Swendi. Dr. Asep Swendi received BSc and MSc from Institute of Technology Bandung, ITB, in Indonesia, and his PhD is from Hiroshima University in Japan. His research interests include physics engineering, aerosol and nanomaterial, and also IoT applications. Currently, he serves as a Vice Director of University Center of Excellence of Intelligent Sensing and Internet of Things, ISIoT in Telkom University. Please welcome Dr. Asep Swendi.
Okay, thank you very much. Okay, can take the slides. Okay, thank you. Okay, good afternoon, everyone, ladies and gentlemen. Thank you for the participation in APWiMob. My name is Asep Suhendi, as previously described by Dr. Fabian. I will deliver the workshop, basic or fundamental device and connectivity for IoT devices. Okay, this is the introduction of my education and also some of my work experience. Okay, next. This is the outlines for our workshop for today. So we have the introduction for IoT device, IoT and also IoT device for IoT architecture. And then we can go deeper to the IoT designs and also IoT use case and some tutorial for device design steps. Okay, next. So of course, we have known this technology development are now very rapid development. So after the society 5.0, which has many things that can save or interact with our lives, it's supported by IoT, big data, AI, and also robotics, which can create or unknowingly trading our daily life to interact with namely robots or instruments that can have our life make our life easier, or sometimes it becomes disasters. But in this information, in this workshop, we can try to develop what the IoT devices, and also what is the IoT as general and the applications. Next. So we have many devices connected to the internet. That's what Internet of Things. So currently, more devices are connected to internet than the number of person in the world. So this maybe after 2020, multiple devices are owned by people or by one person. So the numbers will be increasing dramatically, ranging from a wide variety of application, from personal application to industrial applications. And then also the house or institution buildings application. From personal application, we have smartwatch, smartphones, and also others such as remote toys and many other things that are connected to our self. And then for the industrial application, we have industrial monitoring systems, and for agriculture, many agricultural properties are now can be monitored online using IoTs. Of course, in the automotive and security and infrastructure are very rapidly increasing in use of IoT devices. But also in the application of home application or institutional buildings, we have IoT devices using for appliances, automation, for entertainment, for thermal comfortability, healthcare, and also other instruments. So next, so many things are connected to the internet. So, but how the connected things are developed? So we have the definition of layers of Internet of Things, which many researchers differently describe the layer of Internet of Things. This is one of them. So we have the 1, 2, 3, 4, 5 layers of Internet of Things. So first is the perception layer, the sensor, the physicals that converts the physicals parameters into electronics or data information. So this is the process of data gathering, which convert physical objects using sensor, and sometimes mostly of the IoT devices are used for monitoring, but sometimes it's used the actuators to control or affect the environment or the plant. That's the first layer. The next layer is the network layer, which can transmit the data after the data gathering from the perception layer to the next layer. So the network channel this is using cellulars, 3G, 4G, 5G, and maybe beyond, and also other communications such as Wi-Fi, Bluetooth, and others. So the main purpose is to transmit the data to the clouds. So the data clouds is in the middle layer, the next layer. So in the middle layer, the data is stored, and also can be fetched to get the information. In this layer, we can add also the decision unit or data analysis. And the next layer is the application layers, which maybe this is the only thing that we can see directly, such as the display on our smartwatch, monitors, and our mobile apps. So this is the most representative information that can describe the IoT. But this is the graphic. Sorry. Yeah, this is the most useful or most informative for the users. Please back to the previous slides. Okay, but this is what we call sometimes the smart application, because it can display and then can recommend us how to do or how to use train on our daily life, for example, for the smartwatch. But the important thing, or in the sides of the economy, the business layers is the most important, because the sustainable technology can be supported only by if the business is continued. Okay, so the business model here is a system management to create the chance or opportunity to get funding, and also to sustain the system. Okay, next. So after the layers of Internet of Things, we can conclude that the major components of IoT are things or device which collect the data, and this usually it also included the wireless network. And then the next components is the gateway, which can be an existing gateway, or we can create a personal gateway. Sometimes in the remote area, we must develop the gateway. And then the third one is the cloud, to store and fetch the data. And also we can add the analytics, the component analytics of the data, because the data collected are very, very large data. So we are helped the data analysis can be very helpful to support. So the user interface, the last components can display directly the information that we wanted or very important. Okay. So next, after the major components, we can go, yes, next. We can go down to the, what are these device? Device consist of some sensors, microcontrollers, and also the connectivity modules. And also the network, of course, the existing network or private network and IoT platform, but sometimes, or the agent can only see the application and mobile apps and web dashboard. So in this system, we as an engineer can create these two using the IoT device, which contains microcontrollers, and we can develop a mobile application or dashboard application. This is what we can create. Okay, next. So the IoT device consists of microcontroller, which has processor and storage, and also the connectivity Wi-Fi. Of course, it needs also sensors. So the storage is sometimes or mostly needed because the connectivity sometimes can have problems, but the storage is needed so that the information can be maintained even the connectivity is lost. So these are some examples of one of our products, and also the available IoT device, which sometimes they use plug and play sensor, or sometimes they put some sensor in the device directly, or also some display, so that usually this one used for training purpose or rapid development process. So we can have easier or fast development, but usually used in early stage of development of IoT system. Okay, so the important thing is the sensors and the actuators. Many kinds of sensors, yes, are available today. Yes. Next. So the sensors are very important because that's what relate the physicals or chemicals or information about the environment, information about the light acceleration, electric properties, or important or dangerous substance, and etc. So most of the sensors are readily available, so we can add to the device and create the software to send the information to the clouds. After the sensor, the connectivities in the device, IoT device, are hold most important for the transfer of the data. The connectivities we can select between two important parameters, which is the baud rate and the range. We can use for the short distance, short range, or low baud rates. We can use some Bluetooth or Zigbee and other direct RF communications. But if we want to use a higher baud rate, we can use the Wi-Fi or extended Bluetooth if we want to add the baud rate. But usually in IoT applications, low baud rate is used typically. But sometimes, or most of the times, the sensors for industrial using or in the remote area using longer range communication and the connectivity is needed. So we can use the low power wireless area network like LoRa or Sigfox for up to 10 and maybe now around 15 kilometers at most. But if we still need higher baud rate and long range, we can use the cellular or satellite communications. That's for the sensor and connectivities. Next, these are some connectivity modules already developed by Simcom and also LoRa. This is the GSM and then the LoRa module and also the Wi-Fi module. So we can add these communication modules to our device, to our microcontrollers, and we can have the device of IoTs. Next. So basically, what is or what are we should do to design the IoT systems? First, there are 4 steps. The first are the hardware and software module development. The hardware includes software, sensor, microcontrollers, connectivity modules, and also the software to incorporate all of this sensors, microcontrollers, and also the connectivity. The important things is this part, the design of the hardware and software. First are the data type and the accuracy of the sensors, interval of transmission, data transmission, and so the event or time, and also the design of the powers. Next, for the design, this one is the development of communication interface between sensor, network, IoT gateway, and to the cloud. So in this, connectivity is a whole important part, such as the device spread, how many sensors are placed, what is the topology of the communication, and also the required data rates, how many data rates are needed, and also the network coverage. The next system design is to design and develop mobile apps or web interface. In this step, managing the devices, how can we add more device registrations or delete devices, and so add parameters receiving and processing the message, and also provide APIs for reading the gathered data. So that the application can easily access the information and also give information to the cloud. And then the last one is to demonstrate IoT capabilities by showing the business case. It should be user-friendly, adding notification and easy to use, of course. Next. After we have all the design, we need to specifically design the hardware and also the software. The first is design the hardware. We have several parameters should be addressed, like the IoT design domains, and then the fit of IoT device, which will be in what places it will be applied, or what condition it will be kept, and others. And also we need to design the components, which components used, and also sometimes we can add simulation or validation of the concept or models. And some important part is also the PCB layout. Of course, in the because it used the connectivity or RF radio frequency, the design of the PCB should be considered importantly. And then also the last thing is manufacturing and assembly is process. Next. What we mean with the IoT design domains is the analog and data, digital data, because sometimes sensor used analogs, current, sometimes voltage, or sometimes frequency, but also many of them are digital sensors nowadays. You can have using communication, using ADs or converters, analog to digital converters, etc. So we can have, after the data is digitalized, we can use digital filter, etc. And then also the IoT domains designs means some MEMS or micro electromechanical systems nowadays are produced to create smaller components, but also low power. So it's very important. And then, of course, for the radio frequency, we can use the right devices for the right connectivity modules for the right applications. Next. Okay. Because IoT devices sometimes used in very far away or in very difficult to access placed. So they used batteries. When we use batteries, we need to have low power design, because the device should be available 24 hours and also throughout the years. So we need to have the PCB and we need to have the components with low power features, and also the design of the PCB so that it can have a low power features. Next. I can skip this one for the example of the power energy system. And then after the hardware development, we need to have the software development for IoT devices. We can use readily available application system like Arduino IDE, based in Windows, Macs, or general computers, web-based interface, and then sometimes connecting to existing IoT cloud platform, because nowadays many platform available, so we can choose any of them, and also we can create our own IoT platforms, and also mobile apps for controlling IoT devices. Okay, next. These are the top IoT programming language for devices, gateways, and also the clouds. So the devices, you can use the C, C++, Python, or Java, which are suitable for us or easier to understand. We can use these programming languages in devices and also the gateways. And also for the cloud, we can use the Java, Python, or PHP environment. Okay. After we design the device, hardware, software, so we can send the data to the clouds. We need to select which IoT cloud or IoT platforms will be used. These are some examples of the platform that's readily available that we can use, of course, with the subscription or some even free for limited applications. This ThinkSpeak, maybe the most famous among the students because it's free for students and also for limited application, and it has some other features. Next. This one. So the IoT platform ThinkSpeak, you can have and collect the data and can share the channels like this one. It's everyone can access, can have information on the data. The data is displayed in graphic or chart like this, so they can have information about what time the data transferred or collected and what is the amplitude or the value at that time. Okay, but this one is limited. So the next one, another platform is UBDOT. We can choose with whichever we want, but this UBDOT is have so many readily available widgets. As you can see like this, they have the value chart, bar display, or other display that can be used easily. So we just need to drag and drop and change the size. We can use directly without creating any difficult programming. Okay, next, this one is a platform Antares. It's also one of the famous in Indonesia because this one created by PT Telkom, our telecommunication company. It widely used because it has many examples and documentations, complete documentation from a device design to application and testing of the designs. Okay, next, that's the complete information until the platform, until the data stored in the cloud. The next is how to get the data from the cloud to our mobiles or to our dashboard. So we need some mobile programming. This many of the mobile programming we can use. One of them is the MIT inventor, because this one used basic or block programming instead of text programming. So many of us can create, even if we don't have expert in programming. Okay, next. This is the example of the mobile programming using MIT Inventor. So we can create the programs, drag and drop the parameters, which will be displayed in our mobiles. We can change the value of the labels here and also the content of the text that will be displayed. It can have many screen like we used to do in our mobile application. But the important things or the interesting is they use the block programming. So maybe it's less difficult than if we use another one using Android Studio or others that need more expertise in programming. Okay, next. Okay, next we have have the use case for the IoT. So one of them is the flood monitoring architecture. Here, sometimes you need to monitor the information about the possibility or potential for flood. So we need to put some sensors with IoT capabilities. These are the device. We can have many of the devices depending on our needs, and also the gateways or sensor stations. So the information can be real-timely collected to the internet and also send information to the computers or the mobile application of the like the authorities. Okay, next. This one is what we have been developed and implemented with ICOMs and also the IoT centers. for flood monitoring device in our Citarum River monitoring, and also implemented in Padang area for flood monitoring. So we create some device. Sometimes the device is need to be small, but sometimes it cannot be too small for because there is a need for sustainability, power, not using the we can use the solar panel to create the power, and also we need also battery. So the size is sometimes need to be not the device, but the case and also the other supporting components are make it larger. Okay. And also the implementation, we can have then easier one, like this one, or sometimes we need to put them in sometimes dangerous or difficult to access place, so that because it's placed in the open, so anyone can try to tap in or access this one, it will be dangerous. So we need to have it difficult to be accessed so that no one can disturb the sensor like that. Okay, next. After we create the system, the device, the information sent to the web app, we can have many of the sensor. We can track how many sensor alive, what kind of sensor. We have this information in Indonesia: earthquake, tsunami, flood, and landslides. So this one is the website monitoring, web dashboard. You can add also parameter when they can have information or notification at what level, and also at information of history of how many times the flood or the potential flood occurs in the month. Okay, next. Also have the mobile application. The mobile application sometimes really need it because it can access directly to the person, not the general information. Okay, next. This is another example for health monitoring of patient. The doctor can directly consult with the patient, and also if needed, they can the hospital can address all of the patient and connect it to the special doctors. Next. Okay, so after we have the device connected and then also the application, it can be accessed using this kind of component. So this is the examples of the devices already have microcontrollers and then connectivity. This one using LoRa, and this one using NB-IoT, and this one is using Wi-Fi, but using the ESP8266 for the Wi-Fi modules. Next. This one is one of our product for hardware programming for trainings. So this one can have ESP8266 using our PCB. So the sensors we can put or plug in using analog sensor or the digital sensor, and also we have the output for using relay application. Next. Okay, this one of the examples of the program. Next, do we have still time? Okay. Okay, so these are the example of device hardware preparation steps. So maybe it's common for some people, but I would like to inform this as maybe you have smart or small scale or production or some startup for the device, you can use this start steps. So this is one of the device created with our partners. this look like an Arduino because Arduino is open open for developer, so we can use some. To create this one, we need first to have the schematic diagrams. Okay, next. So this one is the schematic diagrams for Arduino based on Arduino Uno revision 3. So we have microcontrollers, and then for USB to serial communication, and then the ports, and also this power system. So this we can modify it and add to our system depending on our design. But this one is the basic of Arduino. Next, after we have the schematic, we create the PCBs. We can use online PCB creator or developer. So we just need to create the PCB and send the file to them, and then within a week or less, we can have this kind of PCBs, and then we can have the components ready. Next, now for one product, it easily we can use the single solders, but for many, so we can have like some stencils, so we can create the PCBs and then create some PCB with holes. It can be used 1 or 2 millimeters plates, and then we can use some pasta, and then also next we can use the soldering for fast project soldering. Next, this one using the hot air for the SMD components, and we can have this one. So it's quite easier, but it takes some effort or several tries we can add. Next, this is the final, but after the SMD components, we can have the through hole components and use solder manually to get the final of the product. Next. Okay, so this one is the device that we can use for the IoT IoT systems. Okay, I think after that we can use the programming, and this one we used for project for training on also the research in our intelligent sensing IoT. So we hope that with the educational institutions such as the universities, scientific research center, and industry, we can collaborate to create the better understanding and the better use of IoT for our future. I think that's all for my presentation. I hope it's not too boring because it's a basic, but also important for some engineers. Thank you very much.
Okay, let's move to the Q&A session. I will welcome any participants here who want to ask. Anyone? Okay.
Okay, thank you very much. I have one question actually. So when we speak about IoT, basically what crossed my mind is that some kind of procedural steps in order to implement it from sensor until data representation to the users. So my question is that which area of IoT that still an open problems, for example, so we can have some kind of fundamental research in there. So that's actually my question. Thank you.
Okay, again, directly answers. Okay, thank you very much, Dr. Vicky. I think this is very interesting questions. What is the problem that they can be addressed or can be used for research? So one of the problem of IoT is the data integrity. Okay, sometimes the sensor is low cost, so they tend to not stable in the measurement, or sometimes also the connection. So the data sometimes lost. So the overall data for the history of the data sometimes missing in the process. So one of the solution is to create the what you call to extrapolate the data, but using the information or available information that reach the server. That's one of the problems. The next one is sometimes the data send the wrong information or out of range information. This is also should be filtered. So not every data is used for the analytics. So we need to clear or filter out the not unnecessary data. And then also after the data is collected, some missing data should be connected or should be predicted, because sometimes it's necessary to make data information is available for prediction analysis. I think that's most of the problem in the software. Of course, in the hardware design, it's more problems arise when using the sensitive sensors or newly developed sensors. I think that's all. Thank you very much.
Okay. Okay. Is there another question?
All right. My question is basically on the case studies that you have. Interestingly, you shown on the projects that you made or your team have made with apa tadi flood monitoring. Yeah, I was just wondering, you use the solar, it was remotely. What did you use to connect to the cloud? Is it the Wi-Fi or the cellular?
Okay, thank you very much. So the project we are holding for the flood, not only flood actually, it's also the flood, landslides, tsunami, and also other information of potentially hazardous for mitigation. So the project is conducted, led by Dr. Khairul Anwar, and so we have the information for the prevention of the like flood and others, and also the recovery of the system. But for the question about the flood sensors, we use the solar panel because sometimes the location is not available in electricity, but for the connectivity we use the cellular, because most of them are still in the network coverage of the cellular. But of course, the limitation is that we need to provide the data, so we have to address monthly subscription or monthly data usage coverage. We can also use some LoRa connectivity with, of course, but we have to install it on the network that need more or use more devices in the area like that. Okay, so I hope that answer your question. Okay.
Pavin, can I ask because I think that you would use cellular. That my question is, do you have any issues on whether, you know, we have clouds, sometimes it's not connected to the base station, and what's the solution if you have that? That's a question.
Okay, it's interesting question, because we have been implemented for whole 2 years right now. So yes, the problem arises sometimes. So it's It's identified because the data is sometimes missing. Okay, so that's when the time is. There are two reasons. Because the power is lost due to the weather or something like that, that the panel cannot have the illumination enough for the. Of course, we also design it to have at least 2 days without illumination. We can still run, but sometimes it's not enough. Okay, and then the next would be because of the connectivity problem due to rain or even the provider problem. So yes, sometimes the data is lost. We actually don't have the solution for this hardware like hardware, but we need to address it using the software for the filtration and also the prediction of the data. So we use some like box plot. So we remove the unnecessary data, and the lost data we use some prediction between the available data. So like that. Thank you very much. I hope we can more discuss on this. Thank you for the question.
Okay, nice discussion. I think we still have time. I think we still have time around 10 minutes to discuss more. If there is no question.
Yes.
Yeah, sorry. Just okay. I think we still have time around 10 minutes to have some question for Dr. Asep. If there is no question, I think I will ask Dr. Asep. So, Dr. Asep, we already knew that usually cellular network consume more energy compared to the LoRa or even Wi-Fi, and especially 3G consume a lot of energy. So how to compensate or how to decrease the energy consumption in the yes, by using the hardware or software approach?
Okay, thank you very much. This is also the another problem. Yes, using cellulars, we need more power, and also the consumption rate is very high. We can use two approach. First, using the hardware approach, we use the low power components, and then for the next is using software. So as you mentioned, we can for some application we need to have many datas or real-time datas that need to be continued, or sometimes it only need 1 or 2 a day, or in 7 or 10 minutes is enough. So we can approach using the interval time of the data transmission. So by using the longer interval data transmission, and between the data transmission we can shut down or idling the communication module, which include in the feature of the modules. But sometimes, like for the early warning system, it needs to be available every time. So in the software approach, we detect or we read the sensor all the times, but for transmitting data only regular base in with the long interval, or when the reading of the sensor is identified as a dangerous or need to be warned, so the system will deliver at exactly that time. So by using the software, we can we can arrange the interval time, and also still active reading the sensors and delivering the information at the exact time that the problem arises. So that's the approach for those problems. Okay, so by the time we can at least extend the life of the batteries using 50% or up to 70%, depending on the interval of the we can use of the interval time of the delivery of the data. Okay,
okay, thanks. Is there any question from the audience?
Yes. Okay. Thank you very much, Dr. Fabian, and also Dr. Asep, for the tutorial. Okay, so I will try to like this to avoid the interference. Okay, so yes, when we are speaking about the future technology, for example, in the case of the 6G, so IoT is still there, and I think the number will be increasing in the case of the 6G. And then also for the 6G, we have what we call RIS, RIS, or Reconfigurable Intelligence Service. Yeah. So my question is actually, when we talk about the intelligence in IoT, and also, okay, let's talk about IoT itself. Yeah. So is it possible in the future we can have the passive IoT? Means that energy zero or close to zero. If it is possible, how we can do that? Yeah, thank you very much.
Okay, thank you very much. As usual, Professor Harul, question is always difficult. Okay, I try to answer the best that I can. Okay, so it's interesting to have the almost zero power IoT devices. So actually, there are already available some of the sensors that can have lifetime of up to 5 or 10 years using single batteries. So, but the information they collect is only around 1 day for 1 measurement or 2 measurements like that. So that's one of the approach. And then for the system itself, yes, it just go basically down to idle mode, and then using timer, they can, or using watchdog timers, it can wake up at a certain time or certain interval to collect the data, validate the data, and then sending to the internet. But sometimes it depends on the information, also the collected information, how many times a day that can be or need to be sent. And also in the recent development, as I refer to the smart or smart IoT like that, we in the IoT development, we also there is also research on the edge computation. So the information that should be sent to the system is filtered and processed in the microcontroller, so that some unnecessary or unvalidated data could be filtered. But of course, this one needs more power and more process in the software, so it's not related to the low power mode, as you mentioned.
Yes, because like this, the trend for the RIS is the passive hardware or passive antenna, such that even though we have the intelligence there, we try to avoid the use of high power consumption. Yeah, so the trend will be like that for the 6G.
This one is include the power harvesting from radio frequency. Okay, that may be another idea. Thank you very much.
Okay, very nice discussion here. Okay, is there any question, Dr. Vicky?
This is rather confirmation than a question, I guess. You mentioned about the when you have imperfect sensors, for example, and it will result some kind of outliers data, right? So because I mean, when you applied signal processing, there is a kind of robust signal processing, which can based on a robust statistic approach. So is there any work on that directions in IoT actually to remove to make an algorithm robust with the conditions of the imperfect sensors due to many outliers? Okay. Yeah.
Okay, thank you. Of course, I think there are many researchers try to address that problems, but I think it's out of my expertise actually. But one of our college, Dr. Indra Chandra, also used some several approach for the removal of the outliers and also the prediction of the missing data, and also the using some features and like computer applications that can automate the process of filtering and predicting the data in the cloud. So the process is in the clouds and use and design or running automatically. So yes, there are some, but I cannot. I forgot to the name of the research of this. Okay, thank you.
Okay, I think we already come to the end of the session, tutorial session, and please give applause to Dr. Asep. Okay, for the next speaker, will be presented by Dr. Khairul Anwar. He received Bachelor of Engineering from Institute of Technology Bandung, ITB, Indonesia, and also Master and Doctoral degree from Nara Institute of Technology, Nara Institute of Science and Technology in Japan. He holds 12 patents in several communication system approach from USA and Japan. As for the publication, he has published 103 papers in IEEE journal and conferences up to today, and his research interests include coding theory, information theory, wireless communication, signal processing, and quantum communication. Currently, he serves as a director of University Center of Excellence of Advanced Intelligent Communication System, or ICOMS, in Telkom University. Please welcome Dr. Khairul Anwar.
Yeah. Okay. Thank you very much, Dr. Fabian, for a very nice introduction. And before I start my presentation about this 5G Advanced and 6G, I would like to thanks to the committee of IEEE APWiMob 2023. I think this year, this is I become one of the speaker in APWiMob after 8 years. And then at the time, I think Dr. Fabian was also inviting me at the time for, I think, in TSM in Bandung, 2015. Yeah. So I'm very happy for being here again with the committee and with you everybody. And then I would like also to thanks to the IEEE Komsok of Indonesia, and especially Dr. Bambang Setia for the invitation to join this APWiMob 2023. So everybody can hear my voice clearly? Okay, that's okay. Yeah. Okay, so I have 50 slides and my time is only 45 minutes for presentation. I think we have 15 minutes for Q&A. So everybody, I will not ask you to remember all equations. But I think it is better that you can also take some notes such that you can ask any questions. We can learn together, and we can also possible for making collaborations for some topic I present here. Okay, so I give the, okay, please go back. The title of my talk is technology enablers, yeah, for 5G advanced and 6G, intelligent and security for life. So I put the two keywords there. Intelligent is for the 5G advanced, and the security is for the 6G. Of course, both technologies are requiring many other component of technologies, but if in general, if you want to have only two keywords, so please allow me to put the keyword of intelligent and security for life. I am Anwar. Yeah, you can call me Anwar from the University Center of Excellence for Advanced Intelligent Communications, or ICOMS Telkom University. I am also the Vice Chairman of Asia Pacific Wireless Group. Yeah, the office is in Bangkok, in Thailand, and I have this position until 2025. I do hope that I can provide the best contributions for the Asia Pacific Wireless Group. And then I am also the chairman of the research collaboration of quantum technology 2.0. 2.0 is for the quantum information, not the quantum mechanics of the physics. And then currently I am also the head of the Beyond 5.5G laboratory in Telkom University. I do hope that I can provide some keywords to everybody in this conference. Okay, next. Okay, please allow me to introduce in brief our laboratory. So our laboratory started in 2016 with the name of APWiTech, or Advanced Wireless Technology. We received the funding from UK for the first time, and then after that we received big funding, yeah, from Indonesia. And starting from 2020, we changed the name because we are becoming one of the center in Indonesia assessed by the Ministry of Higher Education and also Research and Technology. And then we received the funding 4 billion, and Alhamdulillah until today we can have more than 4 billion to run our laboratory and doing the research. Okay, next. And this is our vision and mission. I do hope that it is also possible for us to have the collaboration here. So we assume that telecommunication is like the tree here, and we have the fundamental technology there. We have information theory, machine learning, signal processing, coding theory. They are becoming the roots and also the tree. And the leaf and also the fruits is the application, product, and devices. We are working on 75% of the classical electromagnetic, and 15% on quantum technology, 5% for molecular communication, and 5% for optical communications. So those are our the percentage of our research currently. Next. And then these are our top 5 products. So the first, we have completed the 5G Merdeka. This is the 5G based on the Open RAN we built by ourselves together with Pak Asep. Yeah, this is the funding under the LPDP from Ministry of Finance of Indonesia. And then we are also developing the high-speed trains. Yeah, and we can reach until 1,800 kilometers per hour. Even though the 6G's target is 1,000 kilometers only, Alhamdulillah, we can solve the Doppler effect there. And then we are also developing the over-the-horizon communications. The target is the communication between rocket and the surface devices. And this is very challenging, everybody. And then currently we are not solving the problem yet, how to make communication with the speed of the rocket until 4,300 kilometers. But maybe using some Bessel functions of the communication, we can do that to solve the Doppler spread there. And then we have also developed and published some technology for the next generation IoT. So we give the name of coded random access. So we have the throughput among others, the highest currently 0.9 until 3.7 packet per slot. And then the technology number 5, this is artificial intelligence and quantum coding theory, and also the quantum key distributions for the 6G. We have made publication. This is in IEEE transaction on communications, and this is just last year, yeah, in 2 years ago in APCC 2021. Okay, next. And then we are in Telkom University under the study of the HARUCA. HARUCA is standing for the Harmonisasi Spectrum Frequency for Indonesia 2045. So we make the ranking of the best 10 technology, yeah, where Indonesia should be expert for this technology. So the first is the 5G Advanced and 6G. And the second is Wi-Fi 6E and 7, and also including Wi-Fi 8. Yeah, but at least we are developing 6E and 7 currently. And then railway, intelligent transportation system, UAS, satellite technology, including HTS, quantum, and also the IoT satellite. And then wireless power transfer, hubs, and also HIPS, and ICE, and also GMDSS and Earth exploration satellite services. So those 10 technologies are already accepted by the Ministry of Communication and Informations to be the technology where, yeah, for the 5 we should be expert for this until 2030, and then this is until 2035, and this is 2045. Those are our strategy. And then next. Okay, let's go back to the ITU. So this is the meeting in December last year. So between 12 until 16 of December from the ITU standardization sector. So the meeting highlights the 5 important technology for the future. The first is AI and machine learning, and also the data. And then environmental sustainability, metaverse, quantum information technology, and also 5G and beyond. So I do hope that I can cover all those important technology highlighted by the ITU. Next. And then everybody, let's see the result of the 6G Summit in Finland in 2019. So we can see here the X-axis is the timeline and Y-axis is the performance. And then we can see here that 5G will be the end of the first S-curve. We know that S-curve is representing the invention of technology, impact to the economy, and then saturation. And then invention of technology, impact to the economy, saturation, invention again, impact to the economy, and then saturation again. And then we can see here that digital radio and software-defined radio has been probably ended in 2020, and then the next we will be using the photonic defined radio, and then in the case for the 8G we will use quantum radio. And then what about the 6G in 2030? Since we are in the middle of those 2 S-curve, what I am predicting is that we will use both the classical and also the quantum here, where the development or the expertise of the photonic defined radio will be more massive in the following years. And then why we will be going to those trend or those technology? Because of like this, everybody. So when we see this curve, the X-axis, this is the size or number of bits, while the Y-axis, this is the resources. Of course, the resources is followed by also the complexity. So in some number of bits, the classical Turing machine will be outperformed by the quantum machine because of the some benefit that we can have in quantum that we do not have in classical. So for some bit, this will surpass the Turing machine. What we are currently using is based on the Turing machine. I will also talk in detail this, but the good event that I think we should recognize is that when the Google in 2019 claimed the quantum machine, the name is Sycamore, did the task in 200 seconds, which the classical computer or even the supercomputer takes 10,000 years to solve. So this is what we call quantum supremacy in 2019. Okay, next. Then let's see the result of the ITU. This is ITU Working Party 5G with the meeting in June 2023 and then just revised in September 2023, just last month. The document and also the meeting, this is not final yet. Final might be in January next year, maybe. This is still under the study, but the sub-working group for this WP5G has decided the new capabilities of the 6G or IMT 2030 is like this. So there are about 15 capabilities of 6G. So the new one is the blue. The coverage, sensing related capabilities, AI related capabilities, sustainability, interoperability, and also positioning. So this is very interesting because this positioning is not the capability of the 5G or 4G or the generation before the 6G, but here we will have the new capability for the case of the 6G. What about the green? So the green color here, it is indicating the enhanced capability of IMT 2030, which was the capability of the 5G. So the new thing here is that the speed, I think the peak data rate here, the peak data rate is targeting until 1 terabit per second for this area. And then the use case, because this is, I don't know, this is luckily the same as the 6G or not. We have the 6 use case. So the first is the 3 of the 5G. This is the immersive AMBB, which is S1 into immersive communications. And then URLLC, which is enhanced into the hyper reliability and low latency communications. And then MMTC, where this is about IoT. It is enhanced into called massive communication. And then the 3 new things, integrated AI and communications, and integrated sensing and communication, and also ubiquitous connectivity. Those are the capabilities and use case for the 6G. I think this is very important for us to highlight because it can give us the new idea for what we should do as the new direction until 2030. Okay, next. Okay, so I try to make simple calculations about comparison between how to reach the 5G and also the 6G case. So as I say that the 6G is targeting beyond 1 terabit per second. And then this is for the case of 5G. Let's say we use the highest bandwidth of the 5G, 400 megahertz, and we use moderate MIMO, which is 64. So when we check the capacity, so the capacity, the target of the 6G is 20 gigabit per second. So when we use, sorry, this is not one. Okay, this is 64, right? 64 and then bandwidth 400, 400 mega. And the rate, let's say that half here, and then modulation is 256, even though the 5G can have, the newest release, 5G can have 1024. That is the newest release, just I think 2 years ago, can have 1024. Then we can have the 137.2 gigabit per second. And when we increase the N here into 128, then we can reach this. But everybody can check here how to reach 1 tera? I think to reach 1 tera, given the same things as the 5G, you need another constant here, another dimension here, which we call K. So K, we need something about 104.6 to reach 1 terabit per second. If you don't have the new dimensions, then you need to have the bandwidth 41.8, not point, 41,856 mega or 41.8 giga. And then I think this is very difficult to reach. That's why we need a new dimension for the 6G. Yeah, this is the challenge for the next. And then to the best of my understanding, that the possible dimension that we can have before the N and B is that the orbital angular momentum, or OAM, with the vortex wave. By doing that, we can put orthogonal wave in one component. Yeah, let's say one component, because this is look like MIMO. So if we have 10, and inside of OAM we have also 10, so we can have around 100 already. So by doing that, we can reach 1 terabit per second in 6G. So this is just a simple calculation how to reach the 6G without doing nothing. So this is not possible. So we need something new for the 6G. Next. Okay, so I would like to introduce to everybody about the new document in ITU that we can refer. So the first is the report of ITUR M2516. Yeah, maybe this is version 0. If everybody can check, version 1 might be available just this year, January or February, might be available version 1. The title is Future Technology Trend of Terrestrial IMT System Toward 2030 and Beyond. So when we check at section 5.8.2 from this document, we have the quantum technology with respect to the radio access network. I will introduce 4 important points there for this one, but not too detailed, because it is not the time to discuss the detail for that. But at least to highlight this, such that everybody can take a look after this conference. And then from this document, this is document number 2. This is June 2023, which is revised in September 2023. The title is the Draft New Recommendations of IMT Framework. So everybody, please remember, this is enabler and this is the framework. They are different. So for the framework, please look at the also similar section 5.8. Yeah, technology to enhance the trustworthiness. So we have here artificial intelligence and the quantum computing there. So I think this is very interesting, indicating that the next generation of the telecommunication is changing. Okay, next. This is the time schedule. This is also from the same document from the Working Party 5D. So the x-axis, this is the time, and y-axis, this is the component. Yeah. So what I said in the previous slide is that first is the vision. Vision, this is in the technology enabler, and then the second is the requirement. After that, the standard. So the target of the requirement will be completed after 2026. And the completion of the standard development is 2030, and then after that, standard enhancement here. And then this is the system deployment for the 6G is just after 2030. Another interesting point is that the spectrum. The spectrum for IMT will be decided in 2 of the WRC meeting. So the first is WRC 2023 will be in November. Today is October, so next month. Yeah, next month. And the location is in Dubai. Yeah. And then we will have again the WRC. This is the proposal, and then this is the decision. Decision will be in 2027. We call WRC 27. The location is, I don't know, I do not check yet, but we will have the location here in 2027. And then after that, yeah. So once it is decided, and then I think the industry will be making the product. So I think this is a good chance for us Yeah, because we are still here, so there is there are many times for us to develop. Yeah. But I think we should develop in a hurry such that we can make proposals, and so the technology can be discussed and can be can support the technology for the 6G. Okay, next. I think this is similar. This is the detail of the 5G advance, but I think currently, because I made the slides last year, yeah. So I think this year the topic for the AI for the physical layer of the 5G advance is becoming advanced too, because here this is for the channel estimation, but I think the next will be more than just channel estimations. Okay, next. This is I took this from the Nokia, yeah, in July 2023. We are still here, and the Nokia is making the prediction about the 5G enhancement will be decreasing after 2025. Yeah, here. And then, but the increase of the development of the 6G will be increasing, I think, starting already this year, and then will be maximum after 2026 here. Yeah, so yeah, I think we still have time to make contribution for the development of the 6G. Next. And this is the possible spectrum. This is, I took this also from Nokia at GSMA ASEAN last month. Yeah. So these are possible spectrum for the 6G. So for the 6G, we'll be using both classical and also the quantum. This is for the classical transmission. So we can have here less than 1 giga until 10 giga and also beyond 100 gigahertz. So for this study, it is already available in the document of the ITU Working Party 5G already. Next. This is my summary related to the difference between 5G, 5G Advanced, and also the 6G. So the big difference between 5G and 5G Advanced is the AI at the radio unit, AI at the distributed unit and core unit. Yeah. So which is not available for the 5G. Maybe 5G, we have also AI, but not at the physical layer. And then for the 6G, we have the new thing here. We keep having AI here, but we have the additional channel here, which we call the quantum channel. While the black line, it is the classical channel. So the quantum channel between the radio unit and also the core unit, and also between the network here, when it is supported by the quantum satellite. Okay, next. This is the prediction by the World Economic Forum. So World Economic Forum has made study in September last year, not this year. Yeah, September last year. The forum stated that the danger zone is after 2030. So this is what we call the threat timeline. The number of years before the relevant threat actors will be able to break the quantum vulnerable system. So because why it is said 2030, because the development of the quantum computer, I think, will be maximum, or will be more advanced after 2030. Maybe currently 2023, it is still not so many quantum computer or industry having the quantum computer. But after this, I think the bank, especially the bank system, should prepare for the coming of the quantum computer, because with the SOR algorithm, for example, we can break almost the security in the existing, especially the RSA. Next. Yes, so this is the some cryptography which has been broken by the SOR algorithm of the quantum. Almost this is everything. Yeah, I mean all here. This is except the GMAC and Poly here. So this is the break by the Grover algorithm of the quantum. And then this is also some comparison when we make the number of bit here. So G is Grover and then S is SOR here. So with a number of bit 1024, yeah, SOR algorithm can break the security within 0.01 second, while the brute force can need 4 times 10 to power 134 year to break the cryptography, the security. So this is the big difference. Yeah. Of course, Grover is actually for the database. It is not for the breaking the security, but we can also modify the Grover for the breaking the cryptography. So actually what we do, what the quantum does is like this. If you have the message, for example, hello, you encode into 2, and then the public key is 5.14. So you make the 2 power 5 modulo 14, you have 4. And then 4 is an encrypted message. This is what you send. And then for the private key for this public key is 11.14. So at the receiver 4 power 11 modulo 14, you have the return back the message here. But the quantum computer can predict 11.14 here very short within a second. So this is the dangerous of the quantum computer in the future. What about the devices? If the car, for example, 5 until 25, it is maybe we can update because this is on the on Earth. Yeah, passport maybe we can update. House we can update. The problem is satellite. If you launch the satellite, and then the lifetime of the satellite is basically it's generally more than 20 years. But once you launch and then you cannot update, so this will be dangerous. Yeah. So I think this slide explain us that we should be aware with the algorithm of the quantum because of the parallel processing that naturally available there. I still have time. Okay. Okay, 15 minutes. Okay, next. Okay, so this morning we have learned about the transistor, and then everybody here, please let me explain about the trend of the transistor size. Yeah, so this is the x-axis is time and y-axis is the size of the transistor. So this line, it is showing the limit to optical lithography, and then this is the atomic size barrier, less than 1 nanometers. And then Professor Suman just explained about the 10 nanometers. 10 nanometers of the transistor, I think still below this line, right? Below this line, but still upper than this line. It means that it is close to the nanoelectronic, because nanoelectronic maybe 2 until 10 nanometers. Yeah. So the trend is like this. So because the trend is going to be very small, then it is this is also reasonable that I guess that the trend for the future is going to quantum. Quantum is subatomic, so less than this one. Or maybe with quantum dot, quantum dot, maybe still close to the nanoelectronic, but the trend is still lower than this 25 nanometers here. So this is the trend for the development of the electronic. Then next. Yeah, this is I just take from the APWiMob spectrum last year. So this is the FinFET has been presented by Professor Suman, and I think the next will be complementary FET here, starting from 2020 and until the next. So this is the development of transistor for about 75 years. And then many people is asking whether this transistor in the future will be supporting the quantum processing or not. Okay, next. Okay, this in this slide, I just want to highlight the basic difference between classical and quantum information. Yeah. So this is the classical wave, and this is the quantum. So we can see that quantum is the form of the quantum is in a packet of energy. So this is we have the sinusoid here, and then with the high amplitude and then going small again. this is a different compared to the classical. In the classical, you have 1 and 0, but in the quantum, you have the all position in here. All this is a 1 qubit, so all position in here you can have. So both of them, yeah, they will provide you with information, while in the classic not. Next. Okay, so another difference is that the circuit, yeah, this is in space, while the circuit for the quantum, this is in time. Yeah, and then for the quantum, we have the no cloning principle, and then reversibility, and then also entanglement, while in the classic we don't have. So this is not reversible, while in the quantum it is reversible. Next. And then another analogy again for the quantum and classical is that for the classic, let's say that we have bit 0 and 1. Yeah, we can represent with the coin here, Indonesian coin. 0, let's say that this is the number, and then 1, it is the Garuda. Then if you have 11 bit or 11 coin, you can store just one number, that is 2021. However, for the quantum, because they are moving, yeah, all position express the information. Then if you have 11 cube quantum bit, you can store all numbers from 0 until 2047 at the same time. So this is very powerful. Next. And then another analogy again is that in the case of the classical bit, yeah, let's say that 1 is spin up and 0 is spin down. And then the question is that what happens if you have spin like this? So in classical, we call that this is error. But in quantum, no, this is not error. In quantum, this is spin up, spin down, and this is, yeah, this is both. This express the superposition between cat1 and also cat0 with probability of C1 power 2 and C0 power 2. Yeah, so in this movie, they are we can express, yeah, that this is the parallel word, right, in this movie. So one word is represented by one state. Yeah. For example, if you have the 2 qubit, you have 0, 0, 0, 1, 1, 0, and 1, 1. So you have the forward. In that, this is just a movie, but I think this is good for us to understand how the parallel word works in the quantum. Okay, next. Another way to understand the parallelism is like this. Yeah, this is what we call the Schrodinger's cat. So the Schrodinger asks for the mind experiment. If you have a cat and then you put in the box, and then in the box you have here the radioactive, and then this is the Geiger count with Geiger counter. So when the radioactive release, this counter goes up, and then this hammer will break the poison here, and then the cat will die. So the question is that when you close the box, the cat is still alive or the cats die. So with this circuit, we can explain the situation for the cat, either the cat is alive or die at the same time. Yeah. So cat 000 means that the radioactive keep, yeah, poison keep, and then cat still alive. Plus, yeah, 1 plus 111. Sorry, not here. This one. 111 means that the radioactive release and the poison release and the cat dead. So this the cat can be alive or dead with probability alpha power 2 and beta power 2. Okay, next. And this is another special case from the quantum. For the classical case, just check only one, but for the quantum, check everything at the same time. So this is will be very fast, and then you just check with which one has the highest probability. That is the answer. And then in the quantum, we have also the entanglement. Yeah. So if you have car here, and then you release the car, so the maximum using the classical physics, yeah, the car will be going until C only. But with the quantum, the car can go until E. With the quantum mechanics, especially with entanglement, the car can go to E. It's bypass this hill. Okay, next. Yeah, with that characteristic or phenomenon, we can have the quantum teleportation. you can transmit the cat psi here, the green one, yeah, suddenly to another location, yeah, using this EPR pair. And then you can also reverse, yeah. Using the quantum, you can transmit 2 classical bit, yeah, instantly. This is why the Einstein said spooky action, yeah, from a distance, because you can transmit cat psi, yeah, instantly to another locations, which we call the quantum teleportation. Next. This is the hardware development currently. This is Google 9 qubit in 2016, and then Intel 17 qubit, yeah, 2017, and then IBM 50 qubit, yeah, and then Google 72 qubit in 2018. Yeah, until now, I think they have more number of qubit to be developed. Next. Yeah, this is if everybody can have the 300 quantum bit, so you can store all numbers of the universe, all numbers of atoms in the universe. So from 1 to this, you can store at the same time. Next. This is the dream of the Japan. Yes, Japan is targeting, yeah, under the Fujitsu project here, 1000 qubit after April 2026. Yeah. Next. IBM, yeah, is targeting this year, yeah, 1121 qubit. And then they are targeting, yeah, beyond 2026 is beyond the 10,000 qubit. So this is very large number of the quantum bit to be developed currently. Next. Okay. I still have time, but okay. So everybody, this is very interesting. Why? Because the quantum, the violate the Shannon Shannon theory, especially for the conditional entropy. This should be, there is a line here. Because the conditional entropy in the classical, this cannot be negative. This always the minimum is 0. But in quantum, because of the entanglement, you can have the entropy A given B here can be negative. So when it is negative, minus and the negative, it become plus, right? So I become bigger. And then with this case, the red region, especially if you are doing the information theory work here, so this dotted line, it is the classical rate. Yeah, this is what we know, with we call, for example, Slepian-Wolf coding. So you can have the R1 should be less than mutual information between A and Z given B, and R2 is the same, and both R1 and R2 should be less than this. But with quantum, we will have the new line here. Yeah. So this is very interesting. With this, then when the two users, mobile phone, yeah, they use the quantum with entanglement, and then probability success, yeah, with the higher rate to access the base station is becoming higher. So this is very interesting. So I solved this problem for the classical one, yeah, in Japan in 2013, and we made publication in IEEE transaction. I used the turbo code at the time. It is difficult, but we are satisfied with that work. But with the quantum, I think we should work again because the rate is now changing with the existence of the entanglement. Next. Okay, so this is I think possible topic that everybody can develop for the quantum with respect to the radio access networks. The first is the quantum Fourier transform and quantum linear solver, and then the second is the quantum k-means algorithm, and then quantum support vector machine, yeah, and then also Grover's algorithm. I think those at least four topics are becoming hot in the future for the quantum with respect to the radio access network as existing in the IETU working party 5D. Next. This is how we can make connection between classical computer and quantum computer here. So everybody, if you are working in the electronic, I think this is very interesting for you. So we have the LPF here, yeah, and then we have a mixer here, and then connect to the quantum computers. Usually the structure is like this. This is the temperature of room temperature here. And then finally go close to almost 0 Kelvin. Yeah, the target is to have the energy here. Yeah, this is, for example, with the F here is 5 gigahertz. So we need the T temperature for the lowest part here, less than 0.24 Kelvin here. So it should be very cold. So by doing this, and then we can have the high energy to make the qubit, to make the photon works. So this is if we want to make quantum computer using electronic. There are around 12 ways to make the quantum computer, and this is just one from 12 ways. Next. Okay, next. This is very important also, everybody, that with the speed of the quantum computer, then we combine with artificial intelligence. Of course, this is separated by the measurement here. We can have the speed. Yeah, this is for the speed because parallel processing and the intelligence. So when you combine the speed and the intelligence together, this will be very powerful here. So we can use for the drug discovery, data encryption, and also the logistic optimization, and also big data processing. So this is, I think, also very challenging topic in the near future. Next. And then I visited Barcelona last time for the Mobile World Congress 23. Yeah. And then this is the demonstration from the Rode and Swart. Yeah. Toward the 6G AI machine learning 5G uplink multi-user MIMO with neural receiver. So they replace all processing, conventional processing with artificial intelligence here. And then you can see here, everybody, this is very interesting that even though we replace, for example, PCCR algorithm, filter B, yeah, turbo decoder, we replace this with modulation and channel estimation, we also replace, but we can reach performance here close to the traditional one. Yeah, so this is very interesting. And then for the quantum, this is also very interesting. This is on the floor. Yeah. So I think this is also the trend of going to the quantum processing. Next. Next, Mbak. Okay, so this is the challenge for the future error correction coding. I just want to highlight that the trend is on the redless coding, where we can use reinforcement learning. So for this one, we need this because the rate should be adaptive to the change of the channel, because the Shannon coding theorem say that error can be made to 0 or close to 0 if R is less than or equal to C. However, the problem is that C is changing following the environment. So we have to make also the R is changing too. One of the technique is using the reinforcement learning. Next. I think you are also expert in here. I just want to highlight that once the problem is nonlinear, then we need more layers. Yeah, more layers, and also good function F here. Yeah, for example, this is the problem of the XOR, which is unsolved in 1969. So next. Yeah. So this is, for example, in the World Cup 2022 last year. So Germany and Japan, the Japan win, and Japan and Costa Rica win. So if it is linear, and then Costa Rica should win, right? Because Japan lost to Costa Rica. But this is because of non-linear. So this is the similar with what happened with XOR. XOR here, 0, XOR 1, 1. Yeah. 1 XOR 0, yeah, 1 again. But 0 and 0, 0, 1 and 1, 0. So this makes the AI in 1969 fail with this, because if you take a line like N here, you cannot do that because we have red here. If you put this line, you cannot do that because we have blue here. So it should be like this. Yeah. So we can do that. Next, by using next again. Next. Yeah, by using, okay, let's next again. by using this very simple layer. You have 3 layers. Yeah, this is input, this is output, this is output layer, and this is the hidden layer here. So by doing this, we can solve the XOR very easily. So we put the function here, hyperbolic tangent for F1, F2, but for F3 we use the linear functions. So by doing this, next, yeah, we can put this is, for example, the input is 0 and 1 only. So with this weighting factor, and the next again, yeah, next, yeah, we can make the errors as close to 0 here after some iterations. So by doing this, we can solve the problem of the nonlinearity of XOR very easily using just this example. Yeah. So we will replace everything, every processing in the receiver, by doing this structure. Next. Yeah, so we also test with some function, and some function works properly and some function not. So I think for the engineers of telecommunication, you have to best select what is the best function here, and then and also what is the best structure of the machine learning. Next. Still have time, but 3 minutes. Oh, 2 minutes. Okay, 2 minutes. I will make this quantum machine learning. So this is, everybody, this is the classical machine learning. You have data set and you have machine learning algorithm, you have output. But for the quantum, you have to make input encoding. So this is the state preparation for the quantum bit, and then quantum processing, and then read out, or this is measurement, and then output. So this is an example of our proposal. We made this publications last year, last year for the quantum machine learning. Just we test how we can to modulate 5G. Of course, with this machine we can do any demodulation, but just for the example, we demodulate the 5G here. Go to the next. So we got surprised that this is the complex BPSK in 5G. Our quantum algorithm can perfectly spare it between blue and red. Yeah, this is between 0 and 1. This is for the case of QPSK. Our quantum algorithm can also spare them. So this is I got very surprised with this, and then we will develop this for any complex modulation in the future for 6G. Next. And then this is our plan for the QKD. So we plan to connect BRIN here, Telkom University and ITB, using this balloon to transmit the QKD to Telkom University and ITB and LIPI, and then we exchange information, and then we test using this equipment. So this is the equipment for the QKD. Next. And this is the algorithm for that quantum key distributions. I can explain later if needed. Next. I think this is the takeaway point. So I have some points for you, such that you can take this in the future. So the first is technology enabler for IMT 23 or 6G, 2030 or 6G and beyond has been defined in ITU M2516, November 2022. And then recommendation for the frameworks, everybody can check from the ITU. So the latest is in September 2023. 6G is supported by 4 pillars, 6 usage scenario, and 15 capabilities. And then AI, including RIS, reconfigurable intelligence service. Quantum technology are mostly the new enabler for the 6G and beyond. Quantum technology has unique behaviors. This is not only two, but the most important are those 2 points. So the first is no cloning. They support for the security, and entanglement. They support for the teleportation, superdense coding, and negative conditional entropy for multi-user access in the future. And then overall keywords, intelligent and security for life. So I do hope that it can be a good discussion for us today. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, we will move to the Q&A session. And is there any question from the participant here?
Dr. Cairo, Assalamualaikum. I think it was a very interesting talk. on quantum computing and etc. Which is that out of curiosity, and you mentioned just now on quantum cryptography. All right, at the moment, most now in Malaysia, in Johor, where I'm staying, there's hype on blockchain, on how it could, on the security of what it can offer to the system, on the decentralization of the security code. How could quantum cryptography or quantum security in general can offer better than blockchain? That's my question. Thank you.
Yes, thank you very much, Dr. Sarifah. I think this is a very interesting question. So when we speak about blockchains, it is a different technology for to the best of my understanding is we have the digital transformations. So 2G, 4G, 5G is at the lowest layer. So in the middle, we have the blockchain and quantum. They are at the same layer, blockchain, quantum, AI, and also cloud. They are at the same line to have the analysis of the data. And then on the top is the digital business. So to the best of my knowledge, first, the quantum and blockchain, they are different. But they are both the tools. And then for the security, the security, okay, so for the quantum, I should explain in 4 points. So quantum can be used for first, computation. The second, quantum can be used for communications. The third, quantum can be used for the security or cryptography. The fourth, quantum can be used for sensing, of which the application is the quantum radar. So when we speak about the security, of course, the blockchain has its own security. Currently, this is for the domain of quantum, this is the classical security. But we can also apply the quantum cryptography to the blockchains too. The problem is that we have to add additional devices such that we can transmit photon. Photon is used for the QKD. Can you? So again, the slide. So the important things, either this is for blockchains or for other technology, for communication is next. Nah, here, up here. So, this one. So here, the important thing is here. This is very interesting and this is very difficult to predict. For example, your information is encoded to 1 and 0. And then if encoded into 1 and 0, you have, or the eavesdropper should detect with Z. With Z key here. But if the key is transmitted in plus and minus, the receiver should detect with X. The question is that the eavesdropper does not know the currently what being sent is 1 and 0 or plus and 1. Because if the key is 1 and 0, but you detect using X, you get it wrong. But if you send plus minus, you detect using Z, this is also wrong. So first, who knows either this is 1, 0 or plus minus is the receiver. I mean the intended user. So if the blockchains can apply this one, I think the blockchain can also use this quantum cryptography for the security in blockchains. So you need additional devices at the transmitter, and at the, of course, at the server of the blockchain, and also at the devices of the users. I do hope that it's answered the question.
Okay, nice explanation from Dr. Anwar. Is there any question from the participants? No?
Can I add a bit? Oh, sorry. Just a bit on it. Because in blockchain, the security basically the code are being transferred with the data that is transferred. I understand what you're mentioning just now. If blockchain can use that theory there, then blockchain can be powerful to use that. It's just that my curiosity, it's just a curiosity sharing and discussion on if you already have that blockchain, how could quantum security able to be better?
Okay, yes. Okay, so I
Out of
understand the direction, yes. Okay, so now the question is that what is the definition of better here? If the definition of better is to make the security stronger to the quantum computer, and then I think you should change the algorithm of the cryptography in blockchains into the, for example, lattice-based cryptography, because currently lattice-based cryptography, it is still unbreakable by the quantum algorithm. But I don't know in the future if the scientists develop algorithm again to break the lattice-based cryptography. So I think you should change the cryptography into the post-quantum cryptography.
Depends on what you want.
Yeah. Yes. Yes.
Okay. Dr.
Okay, thank you very much. I think this one also is based on my curiosity. You mentioned about the Shannon capacity, the maximum capacity of Shannon, and you said that for the 5G to catch the rate for 6G, sorry. So you have to use quantum technology as an alternative, right?
Not exactly quantum technology. Yeah,
okay. Okay, so then does it mean that the existing efforts to increase the capacity of a communication system, let's say using massive MIMO communication and so on, when then the quantum technology exists, is it going to replace all these things? I mean, there is no MIMO communications anymore, and there's no, or we can still use that existing technology in the future.
Yeah.
Okay, thank you.
Yeah, thank you very much. This is very interesting question. Very interesting question. So everybody, yeah, please do not mix up about classical and quantum communication. For the classical, we still use that. So to transfer 1 terabit per second, we need classical currently. I am not speaking about 7G or 8G. I am speaking about 6G only. So for the case of 6G, we still need both classical and quantum. Quantum communication is only used for the cryptography, to send the key, to protect the key, because the quantum state cannot be cloned. So it is very safe to send via the quantum. But the data, the encrypted data, is still using the classic. So we still need MIMO. We still need bandwidth. We still need the classical one for the transfer of the data. But the key is via the quantum. Currently for the 6G. But for the 7G or 8G, I don't know. I don't know in the future. Maybe 10 years later, after 2040 or 2050. Maybe we'll know that. Yeah.
Okay. I think we already finished our session because it is almost 3, so I think we can conclude the session, and please give applause to Dr. Khairul Anwar. Next, I will return this session to MC.
Thank you. Thank you, Dr. Eng Favian Dewanta, for the guide of the second tutorial and invited speaker session. And once again, please give applause to Dr. Eng Favian Dewanta. Excellencies, ladies and gentlemen, before we continue to parallel session, we are now in a break, and the break is around 15 minutes. For those who join the parallel session, please note that our session will start at 3 o'clock. After the break, you can process to your presentation room. Thank you.
Dari modul grafik ada paper itu. Saya mau submit mahasiswa lewat. Kayak gitu kan. Ini yang tahu. Udah selesai. Jurusan geografi. Yang kedua manajemen BTI. Yang bagian SAP ambil satu. Oh, SAP. Dulu SAP, Pak. Ya, bagian politik kontrol. Kita banyak. Oh ya, QA. Saya PP. Projection plan. Kerja tiap hari itu, iya, gitu aja. Ke kantor saya enaknya aja. Iya, memang begitu. Iya, yang penting ada on-call, harus on-call. Jadi kerjaan saya dulu programming itu SAP. Bisnis kan kerja di Astra. Jadi yang bikin Toyota, Nissan itu tim saya. Yang itu sama Daihatsu. Jadi perusahaannya apa? Oh, baru itu ya? Dulu nggak ada ya? Dulu sih Anderson Consulting dulu. Ya, ini consulting. Jadi di proyek dikatakan, nah kita develop dia. Develop, starting, udah lepas. Ternyata saya jadi yang MBTI bisa. Itu tapi berat bukannya Pak? MBTI kan nggak belajar programming kan? Nggak tahu, makanya dia bisa ya Pak. Nggak mungkin selama itu disuruh ngeklik. Dia mungkin ngeklik settingnya, ngeklik setting. Setting isi. Karena ada dua jenis SAP yang ABAP untuk programming, jadi customize penuh program. Ya, teman Bang Ho itu nyari Darmawan. Oh iya, teman SAP juga. Iya, SAP. Kok kenapa Pak? Ya 55 bareng. Oh, adik kelas dia. Dia SAP-nya setelah saya. Setelah saya gitu. Iya. Gimana pertanyaan gimana Pak? Teleportation. Saya kembali ke gimana itu yang dapat pertama ya kan sudah dieksperimen dan dapat Nobel tahun 2022 kan yang teleportation. Terus yang kedua arahnya ya kalau sekarang ya untuk itu, untuk kriptografi, untuk ngirimin key-nya tadi Pak. Itu kan nggak bisa di measure karena kalau di measure langsung collapse. Jadi kayak uang berputar Bapak pegang kan, jadi nggak tahu aslinya gambar apa tadi. Nah itu dipakai untuk ngirimin key yang private key tadi kan nggak bisa dijebol. Enggak, kalau sekarang untuk kriptografi jelas. Tapi kalau untuk aplikasi yang lain saya nggak tahu. Kalau untuk non telekomunikasi. Tadi saya nggak masukin slide santet. Saya udah bikin slide santet. Oh gitu. Iya. Slide santet saya bikin waktu ngajar di itu. Ada yang nanya.
Tapi betul Pak, bisa dijelasin beneran Pak.
Kalau santet kan memang kehendak Allah Subhanahu wa taala, Pak. Tapi saya bedain gini, jadi kalau kuantum kan ilmiah, walaupun efeknya sama ya. Jadi kalau ini diubah state 0 di sana state 0 dalam sekejap mata. Saya ubah 01 ikut 01. Nah, santet kan ditunjuk ke sekitar.
Yang dikirimnya apa gitu. Yang dikirim unit tadi.
Enggak, gini. Jadi kalau
tapi dia bisa mengirimkan sesuatu. Iya, itu ada sesuatu yang dikirim.
Sekarang baru state yang bisa dikirim. Kalau material belum bisa.
Ada Pak. Masuk itu.
Oh enggak, maksudnya saya bukan santet Pak.
Cara saintifiknya. Saintifik. Kalau santet
enggak, kalau ilmiahnya hanya state yang bisa. Jadi state itu diukur, nanti Bapak diukur walaupun jauh, walaupun antar planet bisa. Yang tadi teleportation tadi kan CAT-C itu kan pindah sekejap mata. Itu medianya apa? Oh, pertama harus diikat dulu. Diikat di properti berdua, dipisahkan. Jadi dibuat dulu di awal. Itu namanya di-entangle. Ya, itu lapis itu sama kita. Jadi habis itu dipisah, nanti dia berubah sekejap mata. Tapi kalau nggak di-entangle nggak bisa. Di-entangle dulu. Diikat dulu, habis itu
tapi pasti ada perpindahan kan, nggak mungkin. Ya pasti kan ada semacam media ya, nggak mungkin misalkan tiba-tiba di sini stage-nya dirubah, di sini berubah. Padahal kan ada sesuatu yang
di awal tadi. Nah itu yang
asalnya dalam satu.
Asalnya dalam satu.
Dibagi
dua. Gitu. Nah itu namanya di-entangle. State-nya makanya itu saya pakai dalam pernikahan. Orang baik bertingkat dengan orang baik bisa.
Walaupun bisa lama gitu ya. Kayak anak sama bapak. Ya.
Iya kayak gitu, diikat. Kan namanya entangle, bahasa Indonesianya belitan. Ya,
tapi satu gen gitu ya.
Dibikin dulu satu gen, habis itu dipisahkan secara antar planet dia bisa berubah. Iya, karena kan terikat. Karena terikat.
Anak kembar lebih bisa kan siang sama. Kalau anak kembar bisa gitu.
Mungkin bisa ya, mungkin bisa.
Ini dari ini yang sama, berlian. Ada saya ada kembar. Itu kalau tangan kanan,
oh, berarti itu masuk yang tanggel itu ya, mungkin ya. Nah itu yang tanggal pikiran Allah Subhanahu wa taala. Kalau yang tadi ingat pikiran manusia Pak.
Yang dulu saya itu berapa itu?
Oh iya iya iya.
Di adik saya kan.
Iya iya iya. Iya iya.
Yang satu dari Singapura balik datang ke tangan aja sama dia. Gua tuh sama istrinya dicuekin tuh.
Jadi kalau ilmiah tuh gini, bisa diulangi. Bisa diulangi, bisa dilakukan oleh siapa saja. Bang. Kalau santet kan nggak bisa diulangi. Enggak kan, maksudnya misalkan nyantet Bapak ternyata Pak Vicky kan belum tentu sukses sama kan, tergantung iman masing-masing. Nah itu makanya nggak ilmiah. Terus yang kedua, yang nyantet harus jahat, kalau nyantet baik nggak bisa. Nah, makanya itu berarti nggak bisa dipakai semua orang, nggak ilmiah makanya. Jahat.
Oh yang jahat yang nyantet.
Kalau orang baik nyantet gagal nyantet.
Orang baik bukannya.
Nah itu yang maksudnya tidak memenuhi kaedah ilmiah karena kan
and I will be your chairman for this session. And this session, we will have 3 presentations. Yeah. And before we start, I would like to call all presenters. The first presenter is Uke Kurniawan Usman is present. Yeah. And then the second presenter is Inung Wijayanto. Yeah. And the last one is Balkis Sohiba El Kautsaro. Is okay, thank you. And okay. And before we begin the presentation session, let's do a photo for all presenters for this session. Yeah, I invite you all presenters to come to the stage to take a photo together. Please. Thank you for your time. And before we start the presentation, I would like to inform you regarding the presentation rules. Yeah, basically with the time we have 15 minutes for presentation and followed by 5 minutes for Q&A. I will call the presenter one by one, and then to present the paper. And we will perform this session also for streaming. So for all presenters, please prepare your file in USB drive and collect to the operator and your article. Okay. And for the first presenter, Uke Kurniawan Usman from Telkom University, we will deliver a talk about 5G new radio NR network planning and analysis for Bandung City Center. Okay, so currently is preparing the presentation file. I will invite the presenter to come to the stage. And we are still waiting for the slides appear to the online session. Yeah, I think so. So 15 minutes, Pak Uke, time is yours.
Okay, thank you, moderator. Okay, it's be honor for me for present our research. Yeah, with the title is the 5G new radio network planning and analysis for Bandung City Center. This research is our team, yeah, from Mobile Communication Laboratory. My name is Uke Kurniawan Usman with the corporated. Our team is Zikri, Mr. Doni, Rafi, Haris Fahrudin is all from Mobile Communication Laboratory. Yeah, his presentation is APWiMob.
outline is okay. The next. Okay, this is the outline. Is 5 outline: introduction, theoretical review, methods, simulation, result, and conclusion. Klik kanan. Okay. Objective background is Bandung City Center with the total population is 419,000 people have very high activity and mobility, which must be supported by adequate cellular network infrastructure. Bandung City Center, where there is no 5G network covering the entire area in the 7 sub-district location in the center. We planning is the right one. There's 7 sub-districts. Objective is calculate the number site of network planning, analysis network performance based on SSS, RSRP, SCNR, and data rate parameters. Okay. Okay, scope. Next. Scope of the research is planning 5G new radio. Is carried out the 7th district for Bandung City Center using frequency 3.3 gigahertz and bandwidth of 50 megahertz using 3GPP urban macro or UMA propagation model. The parameter review is study R value is 3 parameters. Conducting design simulation using radio network planning software. Next. There is a 5G new radio of cellular network planning is initiated the 3GPP release 15, which will broadband connectivity. 5G new radio is a 3 use case standard ITU recommended. Next. The planning is 2 sessions is coverage planning and capacity planning. For coverage planning is use 3GPP model is 3GPP standard. Number is 38. Urban macro non-line of sight scheme is used because the research objective is classification is dense urban area. There is a equation, line of sight, non-line equation, cell radius, coverage area, and coverage area is using this equation. For next, there's a capacity planning. Capacity planning is network planning method to prioritize meeting user traffic requirement by taking into account the quality and capacity network. There is a equation used to capacity planning. Next. This flowchart explanation is 6 part step. Yeah, the first step is start the collect the planning, yeah, and after that the processing coverage planning and capacity planning, and then simulation with the 3 parameters, and the last is the finish, yeah, network planning analysis. Next. There is a planning area, and the left one is the software is nrpif.com. Can use the there's many there's a no comprehensive 5G cellular network service available in this area. Yeah, can they use the existing? Yeah, therefore we need the latest network planning provide the better service guarantee for present and the futures. Next, there is a link budget coverage planning and the downlink budget. There's a MAPL 78 dB and the MAPL for downlink at 82 dB. Next, there's a cell use calculation, and the total site calculation is total site using the 3 sector is 9. The downlink is 6. Next, there is a total site calculation is for capacity planning use total set is 2 and the downlink is 10 cell. Next, for simulation results analysis of the required the number of sites. For the capacity planning, the result obtained is 9 sites for uplink and 4 sites in downlink, and the capacity planning as 2 sites and for uplink and 10 sites for downlink. There is a separated to simulation. We use the 1, 2, 3, 4, 5, 6, 7, 10 capacity. Yeah. Okay. There is the simulation result with the atoll simulation. There is SSRSRP is a good value because the value is minus 95 dBm to minus 65 dBm. This average value is minus is 81 dBm. According to standard, KPI is very is good category. There is a RSRP result. Its value is more minus mean 100 dBm of 99%. The indicated value is good to excellent category. Yeah, this is due to placement to site evenly distribution and meet power requirement received by subscriber. Next, there is a signaling supervisor SNR research. Result is good to fair. Is range 0 to 30 dB. The average value is 13 dB. Is a good category. Okay, next. There's SNR result. Its value is more 10 dB. Its coverage percentage 59% as a good category. Is still 41 with R and below 10 dB. It's a poor category. This is because location is site is quite close. Data rate results, data rate simulation results is for downlink site is 100 to 25 megabit per second. Is experience is 10 megabit per second. This simulation results. Yeah. Okay. And next, this data results simulation lowers data rate value is range 120 and 122 megabit per second. Is percentage 2.1%. The value is 125 until 126 megabit per second. As presentation is 97.9%. case, there is a recapitulation of planning results. 5G network planning in 7 sub-district for Bandung City Center is can be said to be feasible. Yeah, so value is for 3 parameters. Yeah, the category is good, and exceeds PMT 2020 user experience data rate. Okay. The last one is conclusion. For one is for capacity planning is needed to Bandung City Center is 9 sites for uplink and 6 sites for downlink. From calculation capacity planning is needed to 2 site uplink and 10 site for downlink. For the simulation, we use the 10 site downlink. The simulation obtained, there is a good category for this result is SRP is feasible. For the simulation is a good category, reminding the it was found the 59% use the SNA more than 10 dB, remaining to 41 at less 10 dB, the full category. It can be concluded the SNR parameter is generate is plan feasible. The simulation result is network planning for data rate parameter is 125 megabit per second. Expect user experience data more than 100 megabit per second. Time is 19.7% is you had a data rate value of more 100 megabit per second. For this result, it conclude the parameter generate is the plan is feasible, that the 5G network planning is 7 sub-district for Bandung City Center can also be said the feasible. Thank you.
Okay. Thank you very much. Give applause for Mr. Uke. Yeah. Okay, for Q&A. Now it's time for Q&A. So please, all attendants here, please, if you have a question for Mr. Uke, for presenter, please raise your hand. Yeah, please.
Yeah, okay. Thank you very much, Pak Uke, for the study and also for the presentations.
Yeah.
So I have the 2 questions. So the first is about sorry, 3. Yeah, 3. So the first is about the radius.
Yes.
What is the cell radius you obtain from this research? And then the second is about the power of the transmitter. So you are using how many dBm or dBW you use for the base stations. And then the third, it is to the best of my knowledge, and also I just checked also the minimum requirement based on the ITU document, that for the bandwidth of 50 megahertz, you should obtain at it is divided into 3. So for the indoor 450 megabit per second, for the urban 390 megabit per second, and then for the rural 165 megabit per second. But you saw that you obtain 125 megabit per second.
Yes.
So would you please explain what happened, why there is a difference in this study? So thank you very much.
Yeah. Thank you.
Please directly answer.
Okay, thank you, Mr. Khairul. The value of
About radius.
the radius is 3.35 kilometers.
3.35 kilometers.
Yes. I don't know.
Power of transmitter.
The area is
5 is reasonable. Okay. So
yeah
what the
3.3 required tax power is uplink is 26 and downlink is 49 dB.
DBM or DBW?
dBm, sorry, it's dBm.
49.
49 for downlink and uplink is 26.
I think 43, right? 43 dBm.
Yeah, as the range is 43 is maximum.
Yeah, but we're using 49.
49. There's a simulation for the because the planning results is we focus the using target the 3 parameters is signal synchronisasi RSRP, then signal strength indication new radio, and throughput is 125.
Yeah, 100. Yeah, this is
Yeah.
my question. Why you are not reaching 400 or minimum? Yeah,
Because
390.
okay, there is no using the 5G neo radio standalone. There
But
is
in the simulation you assume standalone.
no standalone.
Or not standalone.
Not a standalone. Using the 4 LTE.
Okay.
This compatible with the non-standalone. Okay, there is a mix the about the A not B and G radio.
Yeah, for the 4G the max bandwidth is 20 megahertz.
Yeah, using experience is 4G.
So
Yeah,
okay.
because there's a very difficult from our tip is to use get the for the simulation but the 5G 60 50 okay 5G yeah, so the we use the non-standalone method to planning.
Okay.
Okay.
Is it enough? Yeah, thank you very much for the question and also answer. So we still have time for the first presenter. So please, is there any question? No. If no, maybe I have one question.
Please.
Pauke.
Yes.
About actually I am a newbie in transmission, telecommunication transmission. So about the simulation and also link budget estimation. So what kind of assumptions to be as the input of the tools? Because you said in your research you have tools. Maybe this is just general knowledge, yeah, for using the link budget tools, link budget capacity tools. So what kind of assumption that should be input, used as input in the tools to make it more reliable to be implemented in the reality? So
Okay, thank you, moderator. There is many input for simulation. There is so many. Is one is area, kilometer square is and the second one is target user. How many user can services can use the services, and that's network network with the Mac Mbps, and then user per site, and the result is can get the coverage per site, coverage per cell, and cell radius. There is the final is get the how many cell can coverage for the 7 sub district.
Okay.
In the Bandung city center.
Yeah. And in your conclusion, you mentioned that for the uplink and downlink result different number of the cells, right? So which one you choose to make a?
For this research is using the downlink.
Okay.
Downlink.
Downlink numbers of sites. Yeah. Okay.
It's the to maximize the coverage the area for area is 28 kilometers. Yes.
Okay, thank you very much for your answer.
Thank you.
So once again, let's give applause for the first presenter in this session.
Thank you.
Thank you very much. Okay. Okay. Now let's move on to the second presenters. Yeah. Next, I would like to call
Thank you. Good evening, everyone. First of all, I would like to introduce myself. Maybe the presentation. Can you show in the screen? Okay. My name is Sinung Wijayanto. I am from Telkom University, Bandung, Indonesia. And in this time, I would like to present our study entitled. Yeah. Check. Okay. Okay. Let me continue again. Okay, it's no problem. Okay, at this time, I would like to present our study about electroencephalogram signal denoising for individual cognitive ability measurement using independent component analysis. My name is Sinung Wijayanto. Here I represent our team, which is in collaboration between Telkom University and Universitas Islam Bandung. Next. Yeah, the contents of our presentation is introduction, method, result, and discussion analysis, and the last is conclusion. Next. Yeah, as we know that nowadays, as psychology do not only use technical skills to gather the data, and most of them are now shifting to use neurological data to make sure that their analysis to human is being more objective. And nowadays we know neuropsychology, which is actually the branch of psychology that combine the psychology in default and combining it between the input from sensors. Here we use the EEG, electroencephalogram device, to capture the signal of the brain of the participant while they are doing some cognitive tests that performed by the psychologist. And the neuropsychology study is basically to show how various aspects of human brain can be affected by certain points of cognitive, emotional, and other behavioral condition in human. Therefore, as we know that the brain, our brain has unique signal that actually if we pull it deeper, if we dig deeper about the signal, it can give us a lot of information. However, the EEG signal, there is a limitation. If we record the EEG signal directly from human brain, and it is performed by a non-invasive technique, which is we do not need to make operation in the brain, the recorded signal will have a very big noise, or we call it as artifacts. And this condition will be very difficult for engineer to explore, to observe the EEG signal. Therefore, we need to do signal enhancement by removing the noise or artifact in the EEG signal recording. And there are actually several methods that can be used to remove the signal. But this study, actually, we want to introduce that we have a primary data set that we have collected, and in this study we present about how we pre-process or how we make sure our recorded data is having less noise compared to the original data. Next. Okay, for material and methods for this study, we using the electroencephalogram recording, which we obtain by recorded it directly from seven participants. They are from age 11 up to 15, and the respondent here, we asked them to do a GNAT, or a go-no-go association task. It is a method that usually used by psychologists to observe the cognitive of people, yeah. And this GNAT incorporates a response time limits. So the respondent has time limits to make a choice, or how they react is being recorded. And then the recording, we split it into the fast response and slow response based on the time that they need to be to give response from the several words that are being shown in the monitor. Next. And then in preparing our data, we do a basic signal filtering. The filter that we use is a Butterworth filter using the fourth order. And we use it because it is commonly used in processing EEG signal. Basically, we want to remove the power line noise. So EEG signal is basically operate between 0.5 until around 60 hertz. So therefore, we use bandpass filter, and Butterworth is we use it because many other study use the Butterworth fourth order. And then in this study, we also use independent component analysis to remove the artifacts or noise from the EEG signal, such as the eye blinks, the eye movement, the jaw movement, and other body movement that recorded also in the EEG recording. And why we use the ICA? Because ICA is basically a blind component, blind source separation method that it is usually used in separating two mixing signal together by calculating its mixing matrix in so that it can split the mix signal into two separated source. Okay, next. And then the result is that here is the EEG recording that we haven't done anything yet. You can see that the baseline of the signal is varies from every channel of EEG signal. So we record the EEG using 16 channel, and then by the help of doctor neurologists, we can see that there are many artifacts that can that should be removed from the signal. Next. And then by applying the butterworth signal, we were able to remove the baseline, the power line noise, and we capture the EEG signal between frequency 4 until 40 Hertz. And then after that, we process the EEG signal using the independent component analysis to observe whether which one is the which component to get which component is the brainwave or which component is the artifact. So by using visual inspection, we removing several components that included or that contained in the EEG signal, so we can get the good brain signal. Yeah, next. And to calculate the result, we measure the noise EEG signal by using SNR, MAA, and IMMSE. So the results show that by performing the filter and the ICA, we get a higher SNR that indicates the noise signal is good enough to be processed later. And then we have a lower value of MAA. So it's signify the accuracy of the denoising method, and the IMMSE also has the low value, and it show overall good quality of the denoise outputs. Next. However, this study is basically not done. It is not fit. Okay, because we can still develop it, we can still continue because this paper only present is presenting about the denoising process of the EEG signal, so that we have a clean signal, and we also have been submitted our work to publish the dataset, so that the dataset can be accessed by everyone. Therefore, this study show that we have been able to make the EEG dataset that we have collected become clear, and it is ready to be used or to be observed even by the neurologist, by the psychologist, or by the biomedical engineer. I think that's all from my presentation. Thank you. I will give back to moderator.
Yeah, thank you very much for your presentation. So next we have Q&A session. So please, for all participants, if you have any question, please raise your hand. Any question? Yeah, please.
Yeah, okay. So thank you very much, Pak Inung, for very nice presentations. So actually, I still do not get the point. So would you please explain again what is the main contribution of this research? If I am not wrong, so the title is electroencephalogram, signal denoising in individual cognitive ability measurement using independent component analysis. Yeah. Okay. So thank you very much.
Thank you. Thank you, Pak Khairul, for the question. So the main point of this study is there are two actually. The first one, we introduce that we have primary data set. And then the second one, we are performing the denoising of EEG signal using ICA and also using standard filter. And then we compare that the denoise signal is
ICA is this is if I remember, this is 15 years ago or 18 years ago. This is for the blind source comparison. Okay.
Yeah, actually we use this because in EEG signal, basically the signal is smaller compared to the noise itself. So the noise is way bigger than the signal.
So the SNR is negative.
Yeah, SNR is mostly negative. Therefore, to do the denoising, we cannot only use the basic band pass filter or high pass filter or something like that. We need to separate the source because the source itself comes from different physical activities such as head movement, eye blinks, something like that, or maybe simple jaw movement like this. It will cause noise, or we call it in biomedical signal is artifacts.
Okay.
So the artifacts should be removed by knowing where the source of the signal. Therefore, we use the ICA, which is actually maybe long ago, it is old method, but it still can be useful in processing the signal.
Okay. Yes. Thank you very much, Pak. Very interesting.
Yeah, thank you very much for the question and also answers. So next, is there any question for our second presenters? Any question? No? Okay. Okay, maybe the next question is from me. In your work, you used the independent component analysis. So maybe if I can ask another method to do the same purpose for this research, but using, is there any other analysis or maybe any other method to achieve the same purpose?
Okay, there are several methods. One of them is wavelet package decomposition. We can decompose the signal into several. Yeah, we can do the EEG signal denoising by using another method, such as wavelet package decomposition, and we can also use like empirical mode decomposition. This is basically a common method, common method that usually done by biomedical signal researchers to observe the EEG signal. So we choose ICA because ICA is simplest, one of the simple method that can be applied into a signal, EEG signal, something like that.
Okay. So if you said about the simplicity reason, so is there any time concern about this process? Yeah, about the process.
No, we do not concern in time processing, since in EEG signal processing there is almost hard, yeah, to be done in real time processing, because one of the application in EEG signal processing that needs to be real time is seizure detection or prediction in epileptic patient. It is needed for them, but up until now, the application itself for real-time processing has not been able to achieve.
Okay, understood. Okay, thank you for the answer. So, is there any question for our presenter? No? Okay. I think that's all for the question. So I think we can close the second presentation. So thank you very much, Dr. Inung, for your presentation. Yeah, you please you can take seat to your Thank you very much. Give applause for Dr. Inung. Yeah, and before we go to the third presenter, previously I got information for my partner, from the organizing committee, that we there is an additional presenter for this parallelization. Yeah, the next, so become the fourth presenter. Yeah, the fourth presentation will be a paper entitled design and realization of 5G antennas on working frequency 3.5 gigahertz by using LNR to increase gain and meta surface to transform from of polarization. Yeah, authored by Edward M. Hafiz Wiraukta, Yoga Syah Pratama, and Andi Bangsawan M.R. Okay, yeah, the paper that I already told before that become the fourth presenter. So so we have in total 4 presentation in this session. Yeah, so after the that's the information for the additional information, and next we go to the third presenter. Yeah, I would like to call Balki Sohiba El Kausaro. Yeah, she will present a paper entitled "Design of Mobile Application for Monitoring Battery Condition Using Internet of Things Technology." Yeah, is that true? Okay, please take a seat first, and while we are waiting for the slides. And for your information, you have 15 minutes for presentation, and with followed by 5 minutes Q&A. Okay, is it already? Okay, yeah, please start your presentation. Time is yours.
Good afternoon, ladies and gentlemen. Let me introduce myself. My name is Balki Sohiba El-Kosaro. I'm a student from Telkom University. I'm here to present our research. It's about design of mobile application for monitoring battery condition using Internet of Things technology. There are the author, Muhammad Al-Kahfi, Akbar Siddiq, me, and Brahmanti Aji Pramudita. Azam Zamhuri Fuadi, and Ahmad Rizal. Next. This is the outline. First is introduction, and then method, and then result, and the last is conclusion. First introduction problem. Electric vehicles or EV are the transportation type that is expanding rapidly. The core component of EV is the battery, responsible for storing and supplying energy to propel the vehicle's motor. Therefore, the battery needs more attention and maintenance and has a long life cycle. However, the battery are also inherently delicate. They are susceptible to high temperatures, over voltage, and over current, leading to a potential decline in their performance. A supervised system that can inform the battery condition is rarely used. Therefore, the necessity arises for the device capable of monitoring battery condition, thus safeguarding the battery from potential damage. And then existing solution. Battery Management System or BMS is a device that can monitor and control the battery condition. BMS is crucial in using current, voltage, and temperature as a parameter to know the battery condition. By many of those parameters, BMS provides useful information such as overcharging, undercharging, over voltage, and over temperature. This information is important to estimate the condition and extend the battery's lifespan. However, the user usually can't see the battery information directly. Users are used to get information from liquid crystal display or LCD to know the battery condition provided by the manufacturer. This condition could be better since the manufacturer doesn't provide a practicality to the users. And this is our solution, an IoT system to be utilized for connecting the hardware and software, so information on the battery conditions can be delivered to the users. The information system in the proposed system shows every battery parameter data and the battery pack condition on the mobile application. Moreover, the application also can give a warning regarding the battery pack condition. Next, method. The battery monitoring system was designed to observe the battery's current, voltage, and temperature levels. It processes the parameters into the battery informations of every battery. There are three main parts of the battery monitoring system. The input comprises voltage, current, and temperature data. The data was collected from sensors installed on the battery pack, and BMS processed them. There is a microcontroller in the BMS. It has a role in processing whole information from BMS and sensors. Furthermore, the microcontroller will communicate with mobile apps to send the processed data through Bluetooth. Next, this is the flow chart. The design of sending sensor reading data to the smartphone application via Bluetooth connection. It begins with establishing a Bluetooth connection and then transmitting the sensor reading data and finally displaying it on the mobile application. Next. The mobile app was designed to give information such as over voltage, under voltage, normal, over current, and over temperature. The information is battery condition when charging and discharging. This is the threshold value of battery condition. For over voltage condition, the value is more than 16 volt. For under voltage condition, the value is less than 12 volt. For normal or stable condition, the voltage value is more than 12 volt and less than 16 volt. And current value is less than 1 ampere. For temperature value is less than 45 degrees Celsius. And over current condition, the value is more than 1 ampere. And over temperature condition, the value is more than 45 degrees Celsius. In this study,
The examination concentrated of the Bluetooth communication performance. Bluetooth testing is performed by attempting to connect Bluetooth communication with a mobile application on a smartphone and comparing the result from the serial monitor of the microcontroller. Therefore, the sensor accuracy was compared with a multimeter and thermometer. Next, this is the accuracy result of the sensors, including voltage and current measured by INA 219 and temperature measured by MAX 6675 thermocouple. The result demonstrate that the sensors consistently achieve an outstanding performance with an average accuracy exceeding 98%. And the experimental result shows that the sensor have excellent performance when they were tested in 3 conditions such as over voltage, over current, and over temperature. The high accuracy ability of the sensor can affect the response of the proposed system. The proposed system is able to cut the charging process when the voltage, current, and temperature is above the threshold value. Next. Regarding the result, depicts the example of battery information such as over voltage, over current, and normal condition. The application was designed to show information on every battery and battery pack condition. There are 4 voltage information for every battery and information on battery pack condition. The application also has a feature that can show information on battery condition in the message section. This section compares battery pack voltage with the determined threshold value and gives the user important information such as warning notification. Overall, the mobile app and communication has performed as expected. The sensor works with minimal error and high accuracy. Furthermore, the mobile app can also show the information following the data sent by process data from the microcontroller. Next. This is the conclusion. The battery monitoring system has been proposed to inform the user about the battery condition. This proposed system utilized Bluetooth connectivity to send the process data from the microcontroller to the mobile app. IoT technology gives easiness so that the battery condition can be supervised everywhere. The proposed system has excellent performance with minimal error and high accuracy of more than 98%. This performance can affect the proposed system in controlling the voltage, current, and temperature to keep the battery in the allowed condition. I think that's all for me. Thank you.
Thank you very much for your presentation. So let's go to the Q&A session. We have 5 minutes for Q&A. So please raise your hand if you have any question for our presenter. Yeah, please.
Can I see again the title with the research? Okay. I have a question for you. What does function EOT for your research? Yeah. EOT designed for mobile application monitoring battery. There's the handset gives many dashboard to information how to use the condition battery. There is so many equipment, yeah. Is no impact, yeah. So many mubazir. Redundant, yeah. So many redundant for the technology using the monitoring battery condition. That's all. Yeah. Thank you.
Do you get the question? Yeah. currently, is there are so many features in our handheld handset that give informations about our our handheld condition. So maybe the question is, what is the merit of your work to give information about the battery? Well, we know that in the same time there are so many also application in our handheld to show and to give the same purpose of your research. Yeah.
Okay, thank you for the question. In here we use model communication Bluetooth because this model communication doesn't need internet, so we can use this application in anytime and anywhere.
So by the way, what battery, what device battery that you use in your research?
Lithium ion.
So battery with what device that use that battery?
Electric vehicles.
Electric vehicles. So the battery is not our handheld battery, but electric vehicles battery. And then the authors design mobile application for report the battery condition of is that correct? Yeah. Did you already report about the electric vehicles in your slides? Oh, okay. Maybe you can. Oh yeah, in the this. Yeah, especially. Yeah.
Okay.
So the suggestion is please explain explicitly about your research. Yeah, in the title. At least the title or the purpose. Yeah. Okay. We have still any time for Q&A question. Maybe is there any other question? Yeah, please.
Yeah. Okay. Thank you very much. I forgot your name.
Balkis.
Balkis, yeah. Okay, thank you very much for the presentation, Balkis. Actually, I just want to confirm, or maybe, this can be also be regarded as a question. So, currently we, in the commercial product, for example, in the motorbike, we have also application that can monitor the condition of the battery. Yeah, currently available in product nowadays. We can download the apps and we can control even the oil, battery, and many things. Yeah. My question is that actually there are two questions. So the first, what is the unique the unique things from your proposal compared to the existing in the market? The similar monitoring apps. The second is that for the reporting, you use the battery, different battery, or you are using the battery you are monitoring. Okay, thank you very much.
For the first question, we know that there are so many applications about the battery monitoring. So what is your unique features in your work?
In our application, there is a alarm in message section when the battery is overcharging. In the status is
danger, in danger, emergent. Yeah, alert.
Yes.
Yeah.
Alert system.
about the overcharge
No, in status message.
in handset.
Yes.
Handset. Is there any other uniqueness?
I think no.
Or maybe the accuracy, or maybe something that no, the basic. Okay. Okay. For the second question is about the what battery you use to send the message.
Lithium ion.
Yeah, I mean, from the vehicle itself. Yeah, for the from the vehicle itself, the vehicle has a battery, right? That you monitored. That you monitor the condition, right? So what battery you use to send the Bluetooth information or Bluetooth data to the hand? Is that true? Yeah. Okay.
The same battery.
The same battery. The same battery, right? So because the transmitter, you place the transmitter in the vehicles, right? Yeah. Okay, so like we have vehicles, then you place the Bluetooth transmitter on the vehicle itself.
Right.
On the battery, yeah. Battery is also on the vehicles, right?
Yes.
Yeah. So they use the same battery, I think. Maybe because of submitting the data, the Bluetooth data, so the capacity or maybe the capacity of battery also decrease, right? So so it means that your applications also reduce the battery capacity. You consume the energy.
This system is
Complete by
balancing of battery.
balancing means balancing system. I didn't get it. What is the impact of that balancing?
I can.
Okay. Yeah. Okay, thank you for the question and also the answer. And please give applause for the third our presenter. Yeah, thank you very much. So yeah, I also already informed you that we have additional presenter for this session. So we go to the fourth presenter. I would like to call the M. Hafiz Wirauta as our final presenter from Telkom University, and he will deliver a talk about please take a seat. About design and realization of 5G antennas on working frequency 3.5 gigahertz by using LNR to increase gain and measure phase to transform forms of polarization. So now we are currently, do you have any slides? Yep. Okay, so please take a seat first. Now we are currently, we are waiting for the slides to be ready. So while we are waiting, so I will remind to presenter that we have 20 minutes in total
consists of 15 minutes for presentation and 5 minutes for Q&A. Yeah, I think the slides is ready. So please start and time is yours.
Okay, thank you for your time. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Let me introduce myself first. My name is Muhammad Hafiz Wirokta, and today I will present to you about design and realization of 5G antennas on working frequency 3.5 GHz by using LNA to increase gain and metasurface to transform forms of polarization. Next. So this is my team and my lecturer, Mr. Edward. And then there's me, I'm Hafiz Wirokta, and two of my partner, Yoga Syah Pratama and Andi Bangsawang, that unfortunately can attend this meeting on site. So the background is the rapid development of 5G. So 5G lately has grown rapidly worldwide. So we need a reliable 5G antenna design to support this trend. And we are not just creating or building a regular antenna, but we also want to change the polarization, and we want to increase the gain of the antenna itself. So the solution here is, the first is antenna selection. So we choose a microstrip antenna with insert feeding, and then we the second thing is optimization. So the optimization is we add two hardware into this antenna. The first hardware is metasurface to change the forms of polarization, and the second hardware is LNA or low noise amplifier to increase the gain of the antenna. We can skip this. So this is the final result, the fabricated system structure of the antenna combined with the metasurface and low noise amplifier. Next. So here are the system structures. The first one is the microstrip. The second one is the metasurface, and the third one is the low noise amplifier. And the user interaction is, so our system, our antenna system will be placed in BTS for sectoral antenna to support 5G. There's a transceiver, low noise amplifier, and microstrip plus metasurface. But we're currently working only in the microstrip antenna, the metasurface, and the low noise amplifier. So here are the system target parameters. We are currently working on frequency 3.5 GHz. And then the return loss is below -10 decibel. And then the VSWR is 1 until 2. And then the gain is above 3 decibel. And then the radiation pole is rather unidirectional, bidirectional, or omnidirectional. And then the bandwidth is above 50 megahertz. And then the axial ratio, here I want to explain a little about the axial ratio here. So exactly, the axial ratio of linear polarization is infinity, because if linear, the vibration, it's only in y-axis. So there are no limits, so infinity for the perfect linear polarization. But in CST, the software that we are using to simulate this antenna, the limit is 40 that can shown up in the screen. So I write down in this, if the axial ratio is 40, it's it's linear. And if the axial ratio is in between 3 and 40, oh sorry, I want to explain the circular first. If circular, so the axial ratio is as same as A per B. So the actual axial ratio is 1. But in this case, there are a range. If axial ratio is 1 until 3, sorry, we can assume that the polarization is circular. And other than that, we can assume that the polarization is elliptic because A per B. Next. This is the microstrip dimension that I designed. So we use Cooper and FR4. So the patch width is 27.4 millimeters. And then the patch length is 20.4 millimeters. Substrate width is 46 millimeter. Substrate length is 39 millimeters. And then the Cooper thickness is 0.035 millimeter. Substrate thickness is 1.6 millimeter. And then the feed line width is 3.7 millimeter. And then because I'm using insert feeding method, so the insert feeding, the feed line will be 3.7 millimeter. The insert feeding gap width is 1 millimeter. Insert feeding length is 4.7 millimeter. And then we want to stack the microstrip and the meta surface. So we add a spacer hole with 2 millimeter diameter. And then this is the meta surface dimension. We are using asymmetrical design for the meta surface dimension. And the specification is just as like as the microstrip. And here the LNA parameters. We are working frequency in 3.5 gigahertz. And then the gain is above 12 decibel. And then for the noise figure is plus minus 2.89 decibel. And here the LNA datasheet. So we use amplifier in our LNA is PGA 102. And we use the bias T is TCBT 14 plus. So as we can see in the datasheet, in the bottom of the table, in the frequency 3.5 gigahertz, the gain is 12 decibel. And then for the noise figure is 2.89 decibel. And here the LNA S parameter. So for the S parameter or scattering parameter is a measurement method that used to analyze the response and the relation between the input wave and the output in the transmission channel. So here the S parameter in graph. And then in the table, and the decibel value change into numerical, as we can see in the left side of the presentation. And we can get the balance transistor that delta K is 1.45, and then the delta factor is 0.29. And then this is the LNA circuit design and component. Because the transistor is PGA 102, capacitor 0.001 yeah. And then the capacitor 2 is 0.1, resistor 1 0 ohm, 0.25 watt, and then the BST is TCBT 14. And this is the real measurement for the LNA gain that has been tested in a spectrum analyzer, that we can get for the frequency 3.5 gigahertz, the gain for the LNA itself is 13.13 decibel. And here are the LNA noise figure that we test on 25 degrees Celsius room. So the noise figure itself is SNR in minus SENR out. So we can get the noise figure is 4.71 decibel. And then here are the system testing. So we use 2 scheme and 2 method for this project. The first scheme is we test microstrip and the meta surface first. And then the second one is we test all of them that link up together, the microstrip, the meta surface, and the low noise amplifier. And we use 2 methods here. The first method is testing using VNA or vector network analyzer. And then the second one is tilting test. And this is the testing using VNA. Skip. And then this is the tilting test. And then this is the result for the scheme 1. Scheme 1, there is antenna, microstrip antenna and the meta surface itself. We test in the VSWR2, we can get the bandwidth for the real measurement antenna is 122 megahertz. And then this is the comparison with the simulation. The VSWR for simulation is 2. And then for the bandwidth simulation is 205 megahertz. And then for the VSWR, the fabricated, we also put the line in the VSWR2. And then the fabricated bandwidth we can get is 122 megahertz. And then this is the gain result. This is for the simulation that we test on CST Studio Suite. We can get the gain simulation is 3.69 dBi. And then this is the VSWR and bandwidth result. That we can get the, okay, skip. I think it's double. So this is the real measurement for the gain result. Before we count the gain, we need to know the receive power for the antenna. So the scheme 1 receive power and gain result is minus 36.42 decibel. So we can get the gain is 4.61 dBi. And the gain simulation is 3.61 dBi. And here there is the radiation pattern result for our antenna system. The radiation pattern is bidirectional after we test real life. And then this is the radiation pattern result comparison, real life measurement, and the simulation. So the radiation pattern, when it's fabricated, it's bidirectional. But when we tested on CST Studio Suite, it's unidirectional. And then this is the polarization result. So when we test on CST Studio Suite, the axial ratio is 40. That we can assume that this antenna polarization is linear. And then this is the polarization result that we have been count. So if the microstrip antenna polarization with meta surface, the axial ratio we can get is 10.76. And then the polarization has been changed from linear into elliptical. Okay, next. And this is the scheme 2 that connected to the LNA. So the receive power is minus 24.32 dBm. And then the gain LNA is 13 decibel. So based on this formula, we can get the gain antenna plus meta surface plus LNA is 16.71 dBi. It's increasing from the result before. And then this is the radiation pattern result. The radiation pattern is SM is bidirectional, but is wider from before because has been strengthened by the LNA. So the conclusion is the antenna chosen for the system is a microstrip antenna with an insert feeding technique with a 4x4 SRR asymmetric metasurface connected to LNA. And then SRR or 4x4 asymmetric metasurface with a distance of 12 mm can change the shape of the antenna polarization from initially linear to elliptical. And then LNA has been successful in strengthening the antenna gain to 16.71 MHz and expanding the range of radiation pattern direction. And then the last one is the others microstrip antenna design, complete with metasurface and LNA can work optimally at a frequency 3.5 GHz. Rather it's tested on simulation and when it's fabricated. So I think that's all for me. I give back to the moderator.
Thank you for your presentation. Now we go to the Q&A session. We have 3 minutes for Q&A. Please raise your hand if you have any question for our presenter. Please. No question. So any question? Please, Dr. Khairul. Dr. Khairul.
Yes. Okay, yeah. Thank you, Hafiz, for the presentations. I have 2 questions. So the first is about the motivation, why we should transform the antenna polarizations. Yeah, why we should do that. And then related to that is why we should have the elliptical polarization. Yeah. And then the second is that since your target is to increase the gain, yeah, and then at the same time change the polarizations. So what you learn, or what kind of knowledge from this research that you can share to us? Yeah. Okay. Thank you.
The first one about the motivation, why we need to polarize, or need polarization,
To transform.
To transform the polarization. Sorry.
Thank you, for the question, and I'm trying to answer your question. I hope my answer is right to you. So the purpose we want to change the form of polarization itself is because basically the antenna polarization is linear. But to anticipate the loss of the polarization mismatch, which can decrease the receive signal quality, so we need to change the polarization to non-linear. Rather, it can be circular or elliptical. Depends on the project itself.
So for the 5G, what is the polarization of the 5G wave?
The polarization of the
5G signal from the base station.
I think it's circular or elliptical.
No, no. Because the title is 5G. So do you have the study about the polarization of the current 5G, or maybe the standard of the 5G?
For the 5G itself, we are currently just working in the 3.5 GHz that will be the frequency for the 5G.
No. Okay, but actually, for example, the broadcasting TV, the polarization is horizontal. So for the 5G, this is what is the polarization of the 5G based on the 3GPP standard. Might be based on this, and then you can adapt to the what kind of the antenna you should make.
Okay.
Yeah, I mean, yeah.
For that, unfortunately, I didn't learn that part. So maybe I will answer your question in the next time.
Okay. Okay.
So for the third one,
For
is it enough?
the second is what you learn by what kind of knowledge that you obtain by increasing the gain and also to transform the polarization.
Okay. What I've learned from this project is that we can change the polarization by using meta surface, because using meta surface is not the only way to change the form of polarization. We also can use slot, or we can use truncated way to change the form of the polarization itself. So I think that's it for the changing of the forms of the polarization that we can learn. Is we can also change the forms of polarization with another way except using truncated or slot, which is we use meta surface. And then for the gain is we test that we if we connect our microstrip antenna with the LNA, so the radiation pole of the antenna is wider than before, and the antenna is become stronger than without the LNA. I think that's I think my answer is right.
Okay, thank you very much for question and so the answer.
Okay.
And this is the final final presenter. So thank you very much.
Thank you.
So please give applause for our presenters. Yeah, please take a seat. Yeah, and before I close this session, because previously we have already take a photo, but I think our presenter is already yeah. So maybe I would like to, can I invite you all, yeah, all attendants here to take picture to close our session, because this is the end of the on-site agenda. So I invite you all in this room to come to in front of the stage and we take photo together. Yeah, please. Check, 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 check.
Dinner.
Check, 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 check. Check, check. Check, check. Please welcome, check. Check.